Discord. Hello, hello. All right. We have a stream running. Hi. So today, just like yesterday, just like last time, what I want is to continue working on the effect stuff that I started. Man, Rust effects. So we have created this repository. We made some little bit of the of work on this. Looks like it looks like kind of promising actually. So I want to like write something here, a readme, try it in a real use case, and yeah, think about it a little more. Maybe use it in the game. All right. And also continue trying out the Helix editor. So we have Helix. Let's say that I would... how do I add a file here? Open? If I open, do I create file? Open. Open a file from disk into current view. What if the file doesn't exist? If I open readme md, effect system for Rust, save. Now we have this file, right? Okay, so let's say that I'm working on a markdown file in Helix. Also, maybe let me actually start configuring this shit. So, let me take a look at nerdcells, nix files. Where is it? In home Helix, config. Let's see. Line number relative. Okay. Disable the mouse. Completion trigger length is 1. Some identifiers are only 2 characters long. W. Not sure what that means. Insert is bar for the cursor shape when I'm in insert mode. That makes sense. Okay. Editor file picker. Hidden is false. Show hidden files. Okay, yes, I do want that. Indent guys. Render true. So we have the indent guys. Skip levels 1. Whatever that means. Okay. Editor soft wrap. Increase. Okay. Not sure if I want the wrapping to be there. Is this probably is like when you work on the markdown shit. Use normal. Control S is save the file. Control Y is clipboard yank. Control P is clipboard paste before. Control V is clipboard paste before. Huh? Huh? Is it normal that these two are the same? Anyway. One darker mod. Does this mean that modified version of one darker theme? Okay. I see. What about languages? So Haskell, Rust. So for Rust, we're checking using Clippy. Okay. Sure. Rock. Markdown. Using default marksman now. Okay. There is a language server for Markdown, so that is what I'm going to write. Okay, let's do this. Configuration. Sure. Let me quit and let me go to the nix files. Helix. So in home, I want a Helix to be there, right? Make directory home Helix. Should it be in home, actually? I'm not sure. Fine, I'll make it at home. My NeoVim configuration is not in home. It's like global. Just put this in the same thing. Helix, home, Helix, languages. Rust. Flippy. Do we format tomls? What about toml formatting? Extra args is W. What is W? Hello, Arya. Cargo Clippy. Well, I don't have cargo here, obviously, but X run. How am I doing? Doing pretty nice, pretty nice. How are you doing? I always look 10 years younger when you cut your hair and trim your beard. Have you seen me without the beard? Because I do that sometimes too. When like for no reason at all, I just completely delete it. I guess I didn't do it in a long time though. Cool baby. Yeah. That's probably what I look like then. Playing a lot of Armored Core. I don't know, I looked at it for a second, it did not like really interest me much. But maybe I didn't look too long. I looked like for 5 minutes at it. You love Souls games? Alright. Hello, Davey. How are you doing, Davey? Are you working on Linksider, Davey? I am working on Linksider, as you can see. Alright. Thank you for the sub. 9 months. Wow. Alright, you know what? You know what I forgot? I forgot to run the bot. I forgot to run the bot. I forgot to run the bot. Wait, we still did hear the alert though, right? There you go. Now it's working. Now it is working. Confirmed. All right. All right. So this was what we added before. GitHub the command. And then I'm trying to configure my Helix a little bit before we start working. I'm just trying to copy paste NerdSoul's configuration here. Coffee script. What is this? Coffee script? Isn't CoffeeScript a language from like 20 years ago? From 10 years ago? You did hear about it, right? People love that shit. I don't remember anything about it. I remember that it was there, but I don't think I actually looked at it. What was it actually about? CoffeeScript. Announcing CoffeeScript 2? Announcing CoffeeScript 2. What is the date of this page? When was this announcement? The only data that I see is 1999, but I'm pretty sure this is not when this announcement was made. Thomas Fisher made it into ES6, yeah. Isn't it like being the same with TypeScript these days? Like some things from TypeScript get into JavaScript? What is cargo clippy-w that Nertzl has here? What is this? W. I'm not sure. I will ask Nertzl when he gets here, I guess. I'm just going to not have it. And also, I want to have formatting in my TOML files, right? Language. Name is TOML. Auto format is true. Can I do this? Okay. We will try. So this is one of the files. The other file is the actual configuration. So we do config TOML, right? And we want to set the theme to be one dark. Editor. Line number. Relative. Sure. Whatever. Mouse falls, so I don't accidentally click, which happens with touchpad often. Whatever, I don't want it. Completion trigger length, I'm not sure if I want that, but editor cursor shape on insert needs to be bar. That is good thing. Editor file picker, I want to show hidden files. That is true. Editor indent guides. So this seems like a good thing. Render true. Character. What is this character even? Hmm? Not sure what this is. Skip levels is one. Soft wrap, keys normal. Keys normal. I do sometimes press Ctrl S to try and save my file, just like I did in Vim, but I'm not doing this. Ctrl Y to do clipboard yank. Oh, clipboard yank is like from the clipboard. Okay. Ctrl P. Clipboard paste before. Okay, sure. Let's do this. And then inside my config, home nix, I guess. Right? What do I need to do? Yeah, we just insert these files directly into our home directory, right? We do just home file config/helix source is helix, just like that. I still have my configuration for Waybar and for Wolfie. I'm not even using those anymore. And Hyperland. Should I delete them so that I don't, like... We'll see, we'll see. Let's switch to that thing. Hold on, I cannot even switch to that because... no such file or directory, yes, lazy git. And to add these files, okay. This is Helix in configuration. Let's switch first, test that it works, and then push commit. Pim, 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 pim. How did my implementation of sleep go? Implementation of sleep? Oh, I did implement sleep. I mean, it went pretty well. I ended up with having it implemented. It's not that hard. It was not that hard. Helix. So why is my Helix not still using the old stuff? Let's see. Home config Helix. Oh, we don't have anything there. Why not? Why not? Helix. This is just a folder, and this folder has nothing in it. Am I right? What is wrong? Oh, existing file is in the way. Please move the files again and try use home manager switch again. Okay, so this is like an empty directory because I launched Helix before, I guess. Config Helix. We just remove this directory, it's empty anyway, and then we switch to the new version of our like dot files again. So now my Helix has this one dark theme by default. And then and also let's see, Helix home, Helix config toml. Doesn't seem that I have. Arsaka, hello, hello, hello. How are you doing? Doesn't seem that I have the formatting here yet. Maybe they don't have the formatter for toml. Hold on. Helix format toml languages toml files. So this is the thing. So you can like disable auto formatting for Rust. Formatter. Like I need to specify the formatter then, right? Okay, whatever. I will figure that later. For now, this is okay. This is all the configuration I need for my editor, which is nice. this to do, make this work. Okay, quit all. We do helix config. So I can save this. All right, nice. Okay, nice. So now we can start working. We go into projects, Rust effects, right? We open our helix editor here. So here's what we did last time. Source main, right? So we have our effects being listed just as arguments here. Oh, this is not even the effects, right? This is just me doing the shift reset. Shift reset is pretty nice. So I think this is still useful, even if I end up like I'm not using the effect system here. The shift reset mechanism that I have here is kind of nice. And then we have this effects stuff. Can I ask you a question? Would like to extract information from LinkedIn automatically? I have an issue. Okay, sure. I know nothing about LinkedIn though. I think you asked it on like the last stream. And I'm not working with LinkedIn at all. But if it is a general question about like how to work with APIs, from I'm assuming you're using Rust programming language, right? Then I can maybe help you. Okay. So now we have this because this is we have a warning because I have enabled Clippy instead of just cargo checking. Variable declared with type underscore. Let with type underscore. Oh, just type underscore. You don't like that? Clippy? Alright. Fine. What is this? This ref cell reference is held across an await point. True. Rust is 2023, bash stack is 2024. No. I mean, maybe, but Rust is a serious thing, and bash stack is a meme, right? You know, like, the meme of 2024 can be the bash stack, sure. We are doing serious stuff here, though. Glyphs? Okay. I'm sorry. I'm sorry. Why do you think Prime was looking at it? Was it because it was useful? No, because it's a good meme. Rust is 2014 onward if you're doing it right. Hello there, Davros. I thought you were not convinced in the fact that Rust is a good language, like until not so long ago. No, you were stuck in between C++ and Rust for some time, I think. No. All right. Anyway. So what we are doing here is trying to like make the effect system, right? I don't know if you were here on the previous stream, but we want to like have more explicit, more like things like in Rust, your functions, they can panic, for example. That's one a simple example, right? And I want those things to be more explicit. For example, this function can do logging, and this function can do like canceling operations. This function can do logging and can do file system interaction. So we do this explicitly as arguments to the function, so that there is no like hidden stuff. I don't know. I will try to like write down like some text about what I'm doing here today instead of just making it super abstract. If Google provides me with 7 million search results for a query, how can I gather the URLs of all 7 million? I believe it's limited to 300. Well, this means that Google does not provide you with 7 million, right? It only provides you with 300. Is that what it means? And what do you mean by Google provides you with 7 million result searches? So when you, I'm assuming that what you're saying is that when you're using the Google API for searching, right, it gives you the number of search results and then the first 300, the top 300 links. And then if you want to go past the first 300, you need to specifically call the API, please show me the next 300. And then you call this multiple times, and eventually you go to the 7 million, to all the 7 million, I think, maybe. Prepare for the police to show up at your door. No. 3 bash stack is 2024. No. I mean, maybe, but trust is a serious thing, and bash stack is a just 2023. You didn't even like clip it properly. I didn't even the word is not even being pronounced here, so it's okay. I'm not scared for the police. You didn't even clip it correctly. This refstyle reference is held across an await point. Where is it being held across the await point? I'm literally dropping it over here. Look at this. I'm dropping it. I think Clippy is not smart enough to do this. Okay, fine. Let me try this self. What if I do this? If I do that, and then I await. Then it's working. All right. Then Clippy is not complaining. Okay. I don't think it mattered, but sure. Function foo is never used. Function run is never used. Okay. Okay. Nice. Nice. So, what I want is to try and run a readme, right? I want to write something here. I want to write something, and where do I see the default language servers for things? Guides. Languages. Default configurations for languages. Oh, let's see. Bash language server. Look, there is a Bash language server. Is Bad Cop using this? I'll let you know. The cops have been alerted. Sure. Sure. Okay. Language server. Lua language server. Oh wait, hold on. There is a language that's called Toml. Scope is this. Language server is tap low. I think I just need to install this, right? Tap low. Is that what it means? Tap low. What is this? Nix. Run. Nix packages. Tap low. Is that a thing? That is definitely a thing. Okay. Okay, fine. Let's go back. Now, let me open a new one. Nix files. Helix. Where do I install my packages? In the NixOS, actually. Okay. Tap low. Or Toml. Toml language server. Okay, also I want Markdown. So for Markdown, we use Marksman, right? Marksman. Markdown language server. Do I need anything else installed? I don't know. Docker files. Docker language server. There's a lot of things. All right, nice. A language debugger. What do you mean language debugger? Okay, there is a debugger stuff. Debugger name Go? Wait, what? Marksman. Yes. Okay. Oh shit. Why did I close it? Projects, Rust effects. Hold on. All right. So if I open Helix now, and I open like cargo toml, now that I have installed this stuff, am I going to format this? I am, nice. Okay, I have my formatter working. Bog. Tableau Marksman. Okay, nice. I think this is all I wanted. Now we can just like continue working actually. Although one other thing that I want to like know about is so I'm going to write a readme, right? If I was working in VS Code. I could open a preview of this markdown. But what would I do with Helix? Helix preview markdown. Is there such a thing? Markdown preview? Similar to NeoVim? An terminal preview using the built-in markdown view would be a nice option too. I don't think so. It's terrible. I found this markdown server. MDPLS. Like what? Am I supposed to like run as some command in the like that watches my markdown and renders it, right? Preview markdown terminal. Glow. Render markdown on the CLI with the pizzas. I'm not sure what this means. Okay, fine. Whatever. Let's do something. So we are working on the effect system for Rust programming language, right? And one of the hardest parts about this is trying to tell people what this is, right? What is effect system, right? So it's usually like we'll give the example of the fact that you can implement stuff that already exists in your language using the effect system. Like you can implement exceptions. And I think when people hear exceptions, they say exceptions are bad, and so effect systems, they don't even look into them further. So we need to not tell anything about exceptions, right? I need to give another example. All right. Let's like I think and to like split all of the different examples if we're into multiple categories, like categories of effects that we can have in our program. I think the first one is just the like let me call them like tag effects. So this is like a tag on a function, allowing it to be executed only in specific contexts. Like, so in Rust we already have unsafe, right? Is there any other examples like unsafe that we could do with just tagging? So, and then how can you implement this in a more like generic way? You could do function and say function. So instead of writing unsafe, because we want it to be a generic thing, we would write something like like we would pass a variable that is like allowing us to implement this, basically. Does that make sense? I'm not sure. And like coming up with words is hard, right? But I will try. I will try. So essentially what happens here is we moved the unsafe keyword from outside of the function to the inside. And in that, and by doing that, we make it more generic. So it, like, your tag does not have to be an unsafe thing. So this can be just a zero size type. In these specific cases, right? Are there any other examples like unsafe that I would like to list here? I'm not sure. Okay. Then we have unwind effects. So these examples here are like exceptions with throw and catch, right? That's one of the example. Another example would be just like returning from a function, because this is the same stuff. We are unwinding somewhere like to some limit. There is also examples of breaking from a loop, because that is literally like the same thing. Break and return, literally the same thing. So what these effects do, they just go somewhere up the call stack, basically, right? And potentially bring a value with them. Like when you return something from a function, you can return a value. When you throw in, you can throw a value, and you can like catch and handle this specific value, specific exception, right? So basically this means stop executing current function, instead unwind the stack to the closest handler, right? We already have things like break and return. We already have actually question mark. Question mark is technically like returning. Question mark. Honestly, infection would be so awesome to something like unchecked effects, where the tag needs to be passed in, basically telling the system, I know that this is not secure, or I know that this is not logically correct. Unchecked effects. Yeah, I think this. I'm not like sure what exactly you have in mind, but I think what you have like is this like tagging stuff, right? So like in Rust we can only mark our functions with unsafe, but unsafe is a pretty specific thing, right? It means that like it's a pretty specific thing in Rust, and sometimes you want to like mark your functions with some other tag, which is kind of like unsafe. So this is not usual. Like, I know that this is logically correct. Yes, exactly. So like when you use this function, you need to like, because this is not like super well like the logic of this function, in order to work correctly, this function needs to be like called somehow specifically, right? So you need to provide it with like when you call an unsafe function, you need to like create an unsafe context, and for like this other stuff, you need to provide like this other context, right? Something like, I know that using a 512-bit RSA key is bad, but I know what I'm doing. That's what something similar to unsafe for. Yes. I'm not sure if I can write something like this. I think we need to like come up with a more specific example here to put in my in the document here. That is too broad still. I want to come up with more specific example. Like using an RSA key is bad, but I know what I'm doing. I think even like the file system stuff that I had before. Oh, Rust unchecked keyword. There was already a blog by someone. All right, let's see. Maybe we just link to these things. Rust is a language that aims to empower everyone to build reliable and efficient software. In order to do so, several things are built in the language: semantics, saliently, lifetimes, and usage of the unsafe keyword to put it in one stroke. All right, whatever. In this post, I'd like to discuss another check that helps you ensure the correctness of programs, and this is none but the unchecked keyword. Do you know the Rust goal is to ensure memory safety? Leaks are fine, and so is incorrect logic. Yes, so exactly. So we want to ensure more like correct logic. So we want to have more stuff that deals with logic and not just with memory unsafety. Because only a flavor of this Skynet can ensure that your program is logically correct, determining your intentions. Motivation. Let's say we are in a frictious world where financial institutions have more crabs in their offices than cups of coffees. Now, this bank has a library that is used by the bank's developers to program systems that interact with the bank. Also, these libraries have an extreme level of access to the bank transactions. Now, a person who created a library has an overdraft type. This is declared as follows. Apart from all the other associated functions, we'll look at the withdraw and withdraw unchecked functions. Withdraw unchecked means that we don't really check that we have the money to perform the transaction. Is that right? So we just do the transaction even although, yeah, makes sense. The withdraw function is completely fine. It checks the limit and balance before the withdrawal, while withdraw unchecked function doesn't check those. Now, in reality, the withdraw function must have several more things going on than simple conditional things. Think stuff like calculating credit score, etc. This means that the withdraw function is actually pretty expensive to call. That's why the developers of the library provided the withdraw unchecked function that enables. Yes, so like when you expose a thing like that, right? Because this function has some performance overhead, and yeah, so you want to have this unchecked. But in order to use this correctly, the only way to use it correctly is to provide documentation, right? Use this when this use this when the checks, like you are sure that the checks are correct, right? But we want to instead make sure that we like check something before. So, right? Do I want to read this to the very end? I just think that unchecked is too generic. Like what are they proposing here? Because unchecked is like different for all the different logics, right? I want a different unchecked keyword for every single effect. So over here, I want like so like I want to when call this function to tell the compiler that I know that this check has like is okay, right? But not any other check. But if what they are proposing here, from what I can see, is like everything is just one keyword, and that is something that I don't like. They're proposing a new keyword for Rust, like unsafe, but allows to call for unchecked functions. But this is too generic. Like yeah, I like you have multiple invariants that needs to hold when you call a specific function, right? And what if you know that only one invariant is true and the other one is like not true? I want those to be separate. Anyway, let's link this here. Unchecked. Sure. So yeah, if we're talking about unchecked specifically, right? Instead of unsafe over here, I have started writing an example, right? So instead of making this a keyword unsafe, right? I would instead pass a function the tag. This basically is the tag that allows me to perform unsafe operations. And same with unchecked, right? So let's just take a look at this example, right? Since you have linked this, where is it? So we have. We have function withdraw, right? And this does something, right? And then you have withdraw unchecked. But in order to call the unchecked, what I think should happen is that like you need to provide it with unchecked tag, right? Which means that I think what how I would write this code is I would also have check. I would also have a check function, which is the function that returns me this like unchecked tag or whatever. I don't know. Limit checked. This is just a tag that I'm going to construct. Does that make sense? So when you implement this function specifically, you would write something like yes. So this also is an if, right? So this probably returns an option. Let's see. So if let some tag is check, then we do withdraw unchecked using this tag, right? So because our check here, right? We checked that we have enough money in our bank account so that we can perform the transaction. This gives us this tag that we can use to call some other functions. Is this I guess over here Reddit? What did other people say? No one said anything. View all comments. I'm all in for checks and implicitness, but I'm not very interested in this one. The big problem is that unchecked would be much less actionable than unsafe is. Or is that not always possible to like write this code? Is what you mean? So check over here would say like if user has enough money in account, then we return the tag, right? Otherwise, we say that we don't allow you to perform these operations. So I would also like call this like perform withdraw. So in order to perform, we need to know that we have checked the limits of our stuff, right? And also probably, since I don't know, this is probably takes place in our like bank account or something. How do you shift like this? All right, nice. So like withdraw. So withdraw from the bank account. So this takes mutable self, right? So we do instead self check here. Self withdraw unchecked. I think the problem that I see here is like the lifetimes, because like in order to make this properly correct, you would need to make sense that the check is only valid for the current objects, but when you mutate it, the check might start being invalid anymore. But anyway, even if you just do it without lifetimes, this is still like better, right? Something just makes developers actively think about generous functions. So yeah, even although over here, let me finish this example, I guess. Self check, self withdraw, perform withdraw. I guess amount, right? So when we check, let's just write this as a real world example. Check if amount is less than or equal than self max amount that I can withdraw, right? Perform withdraw. Self max amount minus equal amount, like that. So like when we have this example here, technically what we could do is we could call check and then mutate ourselves, perform some other operation, and then call perform withdraw using the previous like tag that we got from the check, right? So in order to make this like even more safe, we would like have to do something with lifetimes here to prevent this thing from happening. Something interior mutability. I think it's not even interior mutability. I think like, okay, if we're talking about this example specifically, I think what I would do is I would make this limit checked. This is going to be not just a tag. It's going to be a struct that wraps around my bank account. So like account is going to be a reference to my actual bank account, a mutable reference. So instead of having this check as a method on my bank account directly, I make it a method on the limit checked bank account, basically. So, yeah. But, yeah. Even although we just have this simple example of providing the tag, it just means that we need to think about it, right? We can like go around and make it wrong, but because this is an explicit argument that we need to provide this this function with a tag, means that the programmer who is using this API is going to think about this tag, probably, right? At least more than if this tag was not present. So this is the purpose of this unsafe, unchecked keywords, right? But for the bank account could have interior mutability via refcell or mutex and then just bypass that limitation. Yeah. Depends on what you actually have in your code. I'm not sure if this is a good example, to be honest, but yeah, I don't know. Anyway, I think this is like the hardest thing to come up with good examples for. The things that are just tag. Okay, anyway, then we have unwind effects. So we stop executing whatever we're executing right now. Not function, I guess. Stop executing like current like statement, whatever. Stop, I just say stop executing. Instead, unwind the stack to the closest handler. So the examples of the unwind effects are breaking from a loop, returning from a function, and throwing exceptions, right? I learned that you can select to the end of the string using t-ret in Helix. It was so simple. Nice. And what were you doing before? Go to line end. So GL, go to line end. So you could instead do VGL to do the same thing, but instead we could just do t-enter. Okay, nice. Okay. Not sure if I mean, I'm not using this editor too well yet. So we'll see if I actually need it. Alright. So do we have another example that is not existing? Yeah. So actually, you know what? I want to give a specific example here. So you know how in Rust, what we want to have sometimes, function. You want to do something like, I don't know. You have an iterator, which is implements iterator. Item is, I don't know, whatever, right? So you do iterator, and then you do filter, and then over here you have a closure x, and I want to do something like if x is 0, then I want to do like, then I want to break from filtering. I want to return from the function. I want to return from the full function specifically, you know? And that is something that is impossible right now, because you cannot return from a function. That is not the current function, and the current function is the closure, right? And I think this is something that would be actually allowed using an effect system, because you just could, right? I need to turn it into a working example. I guess something that happens very often is you going over, like, let's make this specific function that is called sum, right? So you want to sum over the iterator of integers, but those integers, they can be like results, for example, right? Result. And you want to return result. So how would you write this code, right? You would do something like let mute result is 0 for value in iterator. You do a result plus equal value question mark, and then you return the result, right? But this is you can only do this using like fors. You cannot do the same thing. Can you do if else with effect system? I think so. Filter map plus take while. What about this specific example? How do you write this using like your functional code? So you do iterator. Take while plus sum or fold. Yeah, I guess take while it is an okay, and then we, yeah. Take while, does take while do a map at the same time? Actually, no. Sum should work. Yes, but sum is a pretty specific function. Like, how do you implement sum? You know? So are you saying that sum is implemented for results? Just like collect is implemented for results? No, it's not. Oh no, sum result, yes. Yes, okay. So if you can sum the inner value, yes. I'm just trying to like implement this specifically. But this is a very specific thing, right? Sometimes you want not the sum, sometimes you want the, okay, since sum is already existing in Rust, how about we do a, like, I don't know, a product. Is there a product in Rust already? There is. Of course there is, all right. What about something else? What about something else? I don't know. Let's do concatenate all the strings. We concatenate all the strings so that you have an iterator of strings and you can concatenate all of them. Right? Rust with your feature richness. Yes, but okay, this is too specific, you know? You have a specific implementation for product, specific implementation for like sum, but this is not a generic implementation. So like if you have a new operation, you will have to implement like how much code is it is necessary to write the product? Like a lot. This is this can be done in a more generic way, right? Is what we want. Join. Yeah, I guess it's called join. And this is implementing the iter tools. Anyway, it's not only join. It's it's join, but we also have the results, right? So what do you do here? If you don't have the if you don't like the for loop. I mean, essentially, what I want is to have a good example where you, I guess it does filter map. Filter map is what I want here. Filter map, result, and then I do like match result. If it's okay value, then some value. Otherwise, if it's error, then I want to return from this concat function specifically, right? I want to return not from this closure. I want to return from this function from inside this closure using this error. You can have collect. What doing? Result okay is yes. The result okay is like just converting the result into the option. But in case it's an error, I want to propagate this error outside of this function, right? You have collect. That is doing. I'm not sure what that means. You have collect what do an iterator result into result iterator. The collect can make me from collect in Rust. We have the function that takes iterator, that is the iterator over like results, and that returns a result, but not. It does not return the iterator here. Is the problem, right? It returns like a specific collection already, like a vec of t's, for example. So what I want here is to be able to return from the outer function. And then now we have now this gives me basically an iterator just over strings, right? And then I can like do folding and stuff. I want to like come up with an easier. Maybe someone asks a question. Okay. Rust return from outer function inside closure. Someone, is there a way to return from a function from inside a closure? Unwrap or else is another example, by the way. Yes. Because you cannot write unwrap or else and then pass a closure that returns from your function, right? You need to actually write a match expression yourself. We have map while. So like the reason we have those is because we cannot write this directly, right? So we come up with all of these like workarounds. Map while. I don't think I ever used this one. Creates an iterator that both yields elements based on the predicates and maps. So yeah, it's predicates and then it's maps, right? But okay, so but no, this is not a good one because because it doesn't let me propagate the error, right? You could use catch and wind, but stack and winding kind of sucks for performance. Yes, exactly. So we want it to be like, I mean, yes, stack and winding sucks for performance. So yeah, Rust STD is bloated, is what I think. That's why you don't use exceptions for control flow. Because this abstraction, if I could use this is not zero cost. But so you say you don't use exceptions for control flow. Have you never seen people use exceptions for control flow? I know that people do use exceptions for control flow. So since they are already using that, but you shouldn't, but they do anyway. Oh, it's because the exceptions is the way that you can like model this stack and winding thing. Of course, I know him. It's me. All right. You can only use exceptions for control flow. Hold on. Can this be done? Are you saying that this cannot be done without? I'm pretty sure like in this specific example it can be done because our like iterator is going to like compile into a loop anyway. Like this specific example, we already know how to write this code using a regular for loop, right? Over here, we have it. This question mark. In this specific example, sure, yes. So like what are the limits that we can like have to still make it as zero cost abstraction? So like over here, do we really unwind here? No, we don't. But over here we have the inner closure, right? But this compiles down to not like a function call. So yeah. Very advanced compilers to detect this. So yeah, stack and winding is. Hold on, why is stack and winding? Hold on. What is the reason? Hold on. I want to check everything that we. Why is stack and winding bad for performance? Wasn't it bad for performance? Because Because usually when you unwind your stack, you also capture the backtrace. But what if you don't capture the backtrace? Isn't that going to be much better then? Panic is abort easy? Yeah. You can remove some stack frames, but you still need to call destructors? Yeah, sure. Still some overhead, but not as bad. I don't know. I like... So, hold on. So what I want is... so we have learned that there is a take while. Map while. What about other whiles? Is there a try while? I guess there is not. Okay, well, I guess what you could do is you do iterator, take, while... No, hold on. This is so, like... I guess I want something like... This is called acceptable, is basically linked list traversal. Anyway. Filter map. Okay, whatever. For as in result plus equal as. Something like this. So, like, the thing in this example is that we are trying to return not to from the current function, which is the current closure, but to something else that is outside our context. I think this can be a zero-cost abstraction still. I think it can. If you abstracted down, a call stack is a linked list because the stack frame points to the previous one. Yeah. So, like, this return means that I need to return from this function, right? I need to return from this function. So, like, and then return from the outer function too. So, yeah, I don't know. And winding the stack is just returning from functions, no? Anyway, there's another example that already exists in Rust. Technically. Because you can have several loops. So you can have a loop that is called A for X in 1, 2, 3. And then you can have a loop B that is like for Y in 4, 5, 6. And over here you say if Y is 5, then you can already break not from the current loop, right? You can already break not from the current loop, but from the outer loop. So like this example is really similar, right? It's just over here we are breaking from a function, and over here we are breaking from a loop. So technically we're also unwinding the stack here because we are going to like drop anything that like was like allocated here, for example, right? So like this spec is going to be dropped when I break from the outer loop. So it's like it's a similar thing. How is that different than this? Loops don't have stack frames. Functions also don't have stack frames sometimes when they are inline, right? You can do it as so simple in case of a function if it's not inlined. Yes. So if it's not inlined, then like, I mean, zero cost abstraction, it does not mean that you don't like that it's going to be the same. It means that what you would write by hand is going to be like basically same, right? Isn't that the definition of zero cost abstractions? There is cost, but there is going to be cost when you write it yourself anyway. So in order to implement loops, for example, using effects, right? You would write a function like do the loop. This is going to have a function inside. So this is like the body of the loop. It's a function, right? It's a function that you do. You just call this function, and then you do the loop again, right? Using the same body, right? What about negative cost abstractions? Hold on. So how would you implement the loops in Rust without this? So in Rust you have std ops control flow, which is kind of the same thing. So that's how you could implement this. So your function, instead of like your function is implicitly going to basically return here your body of a loop. Basically is an expression that returns whether it should continue executing the loop or break. So you do over here we match executing the body. If it is control flow break with a value, then we return value. Otherwise, if it's continue, then we just do nothing, and we continue executing the loop, right? So this is the abstraction that I'm seeing. So this is what you would write by hand. So in this example, right, you would make this closure return a control flow, and then you forward that control flow if it says like that you need to like break or something. Anyway, I'm trying to be like I'm not doing any progress on what I wanted to do, but okay. I wanted to like write some text here so that I like understand what I want myself, and it looks like we're only making it more confusing right now. To be fair, it's completely possible in Rust if std would handle results like exceptions in iterator functions. Ah. Anyway, so we have async await in Rust, right? And async await is a zero cost abstraction because it has cost to it, right? It transforms your function into the state machines. Is this a zero cost abstraction or is it not? Because async await does have a cost, right? I think I'm going to remove these examples. I want my text in the README to be very small. I'm just going to categorize my effect system. So we have some tag effects. We have not come up with a good example, and like this unchecked is okay, but whatever. I think I need to come up with another better example of a tag effect. Then we have unwinding, right? So unwinding is not zero cost, but that's another question. Not being zero cost, that's another question, you know? I guess a lot of people do like, I mean, I do like the fact that everything is, that Rust has like the zero cost abstractions, right? But the performance of Rust is not really the reason I am using the language. So yeah, that's not like the top priority for me, making sure that the abstraction is zero cost. But it would be nice to have for sure. Anyway, so we have unwind effects, right? Just unwind the stack to the closest handler. And when I'm breaking from the loop, this is technically also unwinding the stack, in my opinion. Or should I call it something else? It's not the stack. We just call unwind to the closest handler. All right. Rust requires non-zero abstractions to be explicit. Well, we are being explicit here, right? Are we not being explicit here? Like return, when you return from the outer function, like we had in this example before. Is this not explicit? This is explicit, right? What exactly is being implicit here? I don't know. Okay, so here's the tag, the unwind. What about the next thing? The next thing is linear effect. Linear effect is the most simple one. So this is just allowing us to call a function. This is just a function call. And then you have delayed execution. So this is what allows us to pause execution and resume it at a later point in time, like async await is the example, right? Are there any other examples? Also, give the code example, please. For what? Hold on. Delayed execution. Also, continuing execution multiple times. So this is specifically the thing that I'm personally not interested in myself. Useful for I don't know. This is not going to be covered, but I can link to something here for async and why it's different from linear. I mean, I think what I want here is to write it for people who understand Rust. So I'm already giving the example, like async await, when you are... I guess the effect itself is the awaiting, right? So when you await, I mean, yeah, literally, the await is like the effect, and async is providing the context for executing something that can do await. So async is basically the handler for the await effect, right? Fine, you don't understand async await. You never used it in Rust yet? Okay. So these are all the different kinds of things. And we can implement just one abstraction that can do all of these basically, right? I'm not sure if I... shit. All right. This is not looking good so far. Do I want to provide it with a real world example? Right? My real world use case is that I want to use it in my game code. Right? Let's talk a little bit about why I want this all. Go buy a Linux key, still not activated, WTF. I don't have any money. I'm broke. Okay. I don't know. I use case. Okay, so we work on the game, right? We work on the game. We work on the game. So specifically, all this started when I wanted to implement the transitions between the game states, right? Writing down words is so hard, guys. Why is it so hard? Coming up with words. Should I just write some code instead of writing words? Okay. Let me get an example from that resembles something that I actually wanted to do, right? So we have a game which consists of the main menu, right? And also we have the play state of the game is also like play the game, you know? So from inside the main menu, I'm just like doing a loop, and if user presses play button, right? If user presses play button, then I do the play game, and then I do play game, and then I continue being in the main loop after I exit from the game stage, right? That is overall what I want here. Async await is just a state machine, basically an enum representing state. Its state is the space between two awaits. Yes, but this is like, yes, that's why I'm using it. That's why I'm using it, because it's the only way in stable Rust right now to represent the partially evaluated function, right? You meant to respond to an earlier message? Oh, to the infinite coder. What is async? You never used async? Yeah. Okay, so this is what we want, right? We want our game code to be very simple like this. We are inside the main menu. If we press the play button, then we play the game, right? And then also on top of that, what I want is I want to have transitions, so that I do like crossfading between different game states and then do the transition back. So basically, let's start with the simple thing, which is my whatever is a game state is something that can render itself into a screen that can render itself, right? So what I want is to have the render effect. The main feature of async is that you can define a custom executor that can run code on awaits. Yeah, kind of. But you don't run code on awaits. It's you define a custom executor that like runs your async code, and like no, async is there so that you can have I don't know. Why don't you isn't it in the Rust book? Rust book. Async. Wait, there's no async in the Rust book, really? I mean, when I was reading the Rust book, it was not in the language yet, but did they not add it? Async. Concurrency. Concurrency, this is like about threads. The Tokyo book. Yeah, I guess the Tokyo book. This is what you want to read, probably. Wait. Well, Tokyo is about all of the Tokyo. We want just the futures. Right? Async in depth. Probably this one. Probably this is the tutorial that you want. Async function as a future. Yes. At this point, we have completely... yeah. How would you contribute into asynchronous runtime model? I think this is what explains how Rust async works, like the wakers. Rust async await feature is backed by traits. This allows third-party crates like Tokyo to provide the execution details. Asynchronous Rust operations are lazy and require caller to poll them. Yeah, exactly. This link. Probably, I don't know. I didn't read this myself. Okay. If we have pressed the button, then we want to play the game. So, anyway, what our game has is, well, whatever. User presses play button. Right, so this is the code that this is what our current game looks like, kind of. It is all async, but whatever. So what we want here is when we, from the menu, go into playing the game, we want to show the transition, right? So we have already this implemented here, right? So we want to transition, like, I don't know, crossfade into playing the game, basically. Kind of something like this. And then when we this is going to be easier if I just work on the actual game code. Let's open the actual game code. I feel lost and like doing too chaotic right now. I will, like, the goal was to try and like organize what I want, like my thoughts on the effect systems, but it's hard. A VS Code, Resident Sleeper. Hold on, it's not even opening. What's wrong with it? Okay. VS Code apparently doesn't even want to open. Fine. Projects. Inksider. Okay, here you go. This is the actual code. So we have source. Play, right? So over here we're playing the game, right? Playing the game, playing the game, playing the game. Over here. This is it. This is it. Wait. Rust Analyzer is actually stupid. I still have this error here. Why? This error literally does not exist. This code compiles. Did I complete the effect thing? My games are so freaking funny, lol. Thank you. Well, what I completed last time is that we implemented the shift reset, which allows me to stop executing the current function and then pass the continuation into some other function, right? So this is working. And then the effects, let's see what we ended up with yesterday, right? So we have this working, right? So this function over here, the simple function, this is like the definition of effects is just like we pass them with arguments, right? So this function can do logging and this function can do canceling. Actually, you know what? Cancel, this is specifically the effect that allows me to return from the outer functions. That is how I would write it. That the example that I was writing before, like when you pass a closure and you want from inside the closure in Rust to return not from the closure but from the outer function, that would be possible to do using this cancel stuff, right? So over here, this returns, but not from the current function, but this goes back to the previous handler of the cancel effect, which is like over here. But yeah, I kind of have it completed, kind of, but I wanted what I wanted to do today is to like write it down in text form and like try to explain it. It's the simplest variant of exception. Yes, it's like the results in Rust, but you, instead of returning the result from a function, you return it somewhere, like, so we delimit it not by just functions, right? You construct a handler that can like take an error, for example. I have a question. How did you create a beach waves in your Sea of Friends games? All right, fine. Let's take a break from our fight. It's not like I'm doing much progress. Sea of Friends. Let me see. Do you think I remember? This happened like a year ago. What exactly are we talking about here? Okay, someone is here. Is this you? Oh, you're talking about this effect. Okay. So this is a shader. This is a shader. This is a shader. I think there is a tutorial on that. Foam, water, foam, shader. I don't remember where exactly we stole it from. I think it was from a tutorial for Godot, and then we like transformed it from Godot into our stuff. But yeah, this is WebGL. Yes, WebGL. I mean, WebGL, if we compile it for the web. I can compile the game for native platform, then I will go into use desktop OpenGL. Or we can also compile for Android. We're going to use OpenGL ES then, right? But yeah. The white thing merging is a cool effect. These things are hard for you to think about. Well, basically what it means is that I can tell you a little bit about how all of this works. So we know the distance from the water surface to the floor of the sea, right? So when you are near the thing, the distance is 0, right? So you can use that distance to implement this effect, and also some noise on top of that. It's pretty simple. So in order to get the distance, we render the sea floor into a depth texture, and we query that depth texture to like know what is the depth actually is. And we subtract that from the depth of the fragment when I'm drawing the surface. That's like the short version of it. I'm not going into too many details. I think you can Google for it. It's kind of easy to find these things. I think we didn't invent this ourselves. It's a brilliant game. It's a pretty good game. It was made for a game jam, just like pretty much everything you see on my H page. So yeah, last time we did make this work. This is a little too verbose though, but yeah. The way this all works is on top of the thing that we called shift reset, because that's what it's called, I think, in other programming languages like Scheme. This is what this is all from. Reset and shift. So resets is basically, so like when you define a function, this gives you basically the limit. This is where you're going to return, right? And this is what is a reset is for. This is basically starting a new like I think they call it prompt in Scheme, right? And does your game also support shaders? Yes, I mean that's pretty much all our game engine supports. We just do everything using shaders, even drawing simple textures. But yeah, the reset is basically the definition of a function, and then we have the shift operation, and the shift operation is the thing that is going back to the reset, basically. So when you call return, for example, you go back to the beginning of the function, and then like you exit the function immediately, right? So this is the similar concept. But also what this allows us to do is it's not only about exiting the function. We can also go so we can go back to like the handler, and then we continue executing whatever we were executing later again. Kind of. I'm moving to Java. It already has effects. Enjoyable to write. It's also super cross-platform. Yeah, it's running on 1 billion devices, right? Hold on. Java has effects? Are you sure? Java effects. Are you saying about this effect? That's a different kind of effect, Java FX. Action that enhances the appearance of the graphics. Java has throws. Throws is just one kind of effect. Just one example. Java is fast enough. I think Java is fast enough for my use cases. But Java has other problems, which is why I don't use it. Okay, so here's our game code, right? So what are we doing here, over here? Look at this. So we are, right now, what if I run it? Cargo run, right? So here's our game, We are over here on a level. And if I go on top of this thing, so this is basically like a teleport into another level. So when over here I press enter, and I'm doing this transition, as you can see, right? I'm doing this transition to go into the inner level. And then I press escape and I go back to where I was. So the way this works is I literally just call a function, kind of, right? It's a little more verbose than that, but still. So over here, this state new, this means that I am creating the new game state that allows me to play the inner level. And then I'm drawing the transition. So I'm doing this visual effect of me transitioning into the inner level. I'm waiting for the effect to complete, and then I'm running the inner state, right? So I'm playing the inner level up until like I win this level or I press escape. Then I return back to executing this function and draw the transition of me going back. Right now I'm using the same transition effect visuals, but it could be different. Whatever. So this is what it looks like right now in code. I'm not sure why my Rust analyzer is so stupid. This code literally compiles. What should I do to make it not be stupid? Clean and recompile everything from scratch. I mean, 60 FPS is achievable even in JavaScript. Java is even faster, so Rust is also very good, but there are no high-level APIs for speeding up development right now. I'm not sure what you mean. I am literally using Rust because it's a higher level language than Java. What do you mean by there are no high-level APIs for speeding up development? Because I think Java doesn't have high-level APIs. Lol, you had to create your own game engine. I did not have to create my own game engine. I could have used something that existed. I just chose to use my own. I tried Bevy for a second. I didn't like it. The game I'm working on right now was originally made in Bevy, and then yeah. No one has to go that far. If I went this far, it doesn't mean that you have to, right? Like I'm doing experimentation. That's like one of the things that I like to do. That's why I have my own custom game engine. That's why I'm right now trying to like make an effect system in Rust, right? Instead of working on the game, I'm trying to make something that is easier to work with. Yeah, you don't have to create your own game engine. Mm-hmm. Okay, cargo check, cargo run. If I recompile this from scratch, is Rust Analyzer going to be complaining about all of this again? Raylib seems to be the winner here. I guess Raylib is not bad. Maybe. I never tried it. Before Rust, I was using C# and the whatever, mono game toolkit or something. I don't remember. What was it? Okay, so here's the problem with what I have right now. So right now, if I am over here, I'm going into the inner level, and while this transition is happening, right? While this is happening, I cannot go back. So I cannot interact with the game while the transition is happening, which is like not too bad, but sometimes I actually want that, I think. You know what I mean? Yeah, it looks like Rust Analyzer is fixed now. I think this happened because I updated my Rust to 172. And yeah, it broke the Rust Analyzer for some reason. Okay, so here we go. We have, yes. So we are running our inner game state over here. And this is when we can interact with the game. But while I'm doing this transition over here, over here, I cannot interact with the game. And that is one of the things that I want to fix, right? And then also over here, after we exit the inner level, we are going back to our current game, right? So what I want to do here is to continue executing current function while also rendering the transition effect. So here, I think over here is where we want to use the continuations actually. So I'm not sure what the API should actually be here, but I am guessing that the transition should take the should take something that can like render the previous game state and then the next game state over here. So the next game state here, I think, should be the continuation of the current function. Is this what I want? Hold on. I think this is what I want. So the current continuation. In order to get the current continuation, we just implemented this in our like effect library, right? So we do the reset, and then the reset operation gives me the shift handler, shift, right? And then we do here async move. How do I select multiple lines in this? Oh. How do I select multiple lines? If I go up, then it starts from the beginning. No idea. Okay, so over here we do reset. No, we don't. We don't do the reset. Hold on. So I want over here to pass as an argument to this function the continuation of the current function. So like whatever is happening next, so like me playing the game, basically, is going to happen at the same time as me drawing the transition. Is what I want here. Can I make this in the engine? It's hard to like understand this a little bit. Press V and move anywhere you want. I press V, but it starts over here, right? I want to select like full lines. not partially these lines. Oh, and then I press Shift X and it does that. Okay, that's probably it. Did by placing cursor where I want to start and pressing X, it works, but it only works down. I think I just figured it out. So I go into the visual selection mode by pressing V, then I go up, and then I press Shift X, and it selects the actual lines. Looks like that is working. I need to start making some progress. I've literally done nothing so far in the 2 hours. Excellent card lines. X adds new line to selection. Alright. Yes. Rust syntax is so scary than C++ or Java. I don't agree. But alright. I'm not trying to make you use Rust, right? I think I can embed this effect system like in the engine or something. Because we are already working on top of the async await. It's not going to be that hard to do. I think. Have you seen C++ Lambda? I don't mind C++ Lambdas anyway. I don't know. I overall I don't think any language has like ugly syntax. Like syntax doesn't matter, in my opinion, that much anyway. What am I trying to do? Guys, I'm lost. What was I doing? I had a plan in the beginning of the stream and now I'm lost. What I wanted to do is I wanted to write a readme here to write about the effects. And then help, I found something cursed. Don't be lost. Hello Nerdsoul, how are you doing? The box and borrow stuff looks new and scary. Well, the fact that it's new means that like you need to learn it and then it stops being scary. It's not that hard. What is this? PHP Tokyo. Use any async Rust library from PHP. This library allows you to use any async Rust library from PHP asynchronously. It's fully integrated with Revolt. It allows full compatibility with these things. I don't know. I never used PHP. I mean, I used it once. It didn't look like too bad. I mean, it has these dollar signs which look a little ugly, but other than that, it's just a language. Doesn't look much different from other languages. PHP now have traits. Oh, speaking about other languages that have new things, did you guys see that Python is going to have generics? I'm not sure. They what? Hold on. This is a Russian thing. Do they have a link somewhere? The PAP 464. What is this? A Algebraic generics in Python. Did you see this? They are going to have this in Python 3.12, which is going to be released in October, I think, or something. So, I don't know. You have over here a two-dimensional array with height and width. You can have look over here. You have a type variable t, and then you have this, whatever this is. Hold on. Is there an example of specifying a generic function in this language? Yeah, I've been through similar phase in Scala as well, and now Scala is dying. So isn't Scala one of the languages that has algebraic effects? Scala effects? Scala algebraic effects. This one has it, right? This is so long. Look at this. What are they doing here? Why is this so long? Generics in Python. I'm trying to find an example of the generic function and I'm not seeing it for some reason. Look at this over here. Define foo f is callable with int and something. You know, it's like this is almost like Rust at this point. Impl fn, you know, with int, returning a tuple. I'm not sure what they are doing to Python here. Anyway. Funny. I was so hyped up with Scala 5 years ago. Now Kotlin probably taking the lead, but Rust is nice overall. It has taken the cool stuff from Ruby. Ruby what? Avoid explicit return, variable block assignment, etc. Ruby is not the only language that has it, right? Yes. All right. By the way, Nerdsel, did you see what we ended up with on the last stream? Like, our effect system is kind of working. Even although I'm not really doing, like, much today yet. I'm trying to do something and I don't know. It's weird. Here's the example, right? Here's the example. Okay, let's go over this again. The plan was today that 2 hour in and not yet. Yeah, like I wanted to like write the thing that I did on last stream and turn this into text, and like I don't know, words are hard. So yeah, here's our simple example, right? This is a function that like has the logging capabilities and like canceling. AD or GNOME, this is GNOME. And over here, you just do this. Here's the combined effect. And over here, I'm specifying the handler for canceling. This is a little too verbose, but at least it's working. In other aspects, GNOME is terrible. In which aspects? Can you be more precise? Just saying something is bad doesn't mean it's bad. What exactly is wrong with GNOME? Speaking of OCaml, I want to learn it someday, and I want to learn some Lisp. I have been reading a little bit about Scheme, because like we implemented this stuff using reset and shift stuff, right? So this is stuff from Scheme. I think like this is a nice thing, at least, that we have implemented last time, even if the effect system is not looking too well, too good right now. The shift reset is kind of nice. It allows me to have the to work with continuations in Rust, basically. Too many languages discussion are breaking my brain right now. Yeah, my brain has been broken today too. Okay, I need to think. What are we actually doing today? What are we actually doing today? Hold on, Nerdsel, maybe you can help me. So you have not seen what I have done last time, right? Hello, Icy. This is what I have done. So our effects are basically just arguments, regular arguments to your functions. So you can just give an argument to a function that allows your function to do logging, for example, right? You just give it an argument that implements the log trait. You give it an argument that implements the cancel trait, right? So this is basically, I guess, you know what? How to make this more recognizable. So this is more like throwing, canceling, right? This is like returning from a function, or breaking, or throwing an exception. Is cancel like, does cancel make sense, or should I like rename it so that it's more recognizable by other people? But anyway, what it does, it's cancel the execution, right? Your internet is laggy. In case you missed something, okay. Okay, so here we go. So in Coca, this would be written as something like function simple, and this has the log and cancel effect, right? And this function returns an integer, right? So this is what you would write in Coca. You just do log hello. You would just write log world, and then you would do cancel with 4, and you would write log this will never be logged, right? And then you return 10 from here. Just say 10, right? So this is Coca, and this is Rust. So we implement everything on top of async. So we need to do async await here. So instead of having your effect as specified is in the function signature, you literally explicitly pass. Basically, this is the effect handler. You have the reference to your effect handler directly. Look how much Rust is bigger. Rust is more explicit and verbose, and also we implemented on top of async await. That's the only problem. Why it's looking bigger. Now make your own language. Well, before making my own language, I want to like understand what I want, right? Properly. So I'm trying to implement this in Rust, even although it may be like more verbose. We need to understand. Rust is shame to our world. What? But yeah. Or do it with proc macros. Yeah, or we could do it with Rock Markers. But no, I don't want. I don't mind this being this thing, because like a lot of code that you write is already async await anyway. Like especially when you are like working with Tokyo, for example, all of your code is async await anyway. So it is not going to matter that much. You still do an async for your function, and you are still doing await. And the difference is like, I don't know. So this syntax is not there in Coca, right? You are not really like naming those. But I don't know. For most games, memory management is not worth it. Most games have objects that are created once and live forever. Even particles can be recycled. I'm not thinking, like, I'm making games and I have never been thinking about memory managements. I'm not even using arenas. I don't care about performance. My games are working fine. I'm writing them in Rust and I'm not thinking about memory management. So I'm not sure what your point actually is. But yeah, do you see this Nerdcell? Is this good? Does this looking good? So over here we have a cancel, right? I guess I don't have an example of the continued. It doesn't make sense, but maybe it works. It does work. It does work. He was referring to the smart pointer and stuffs of C++. Well, I mean, in Rust you also have the smart pointers, which is the RC, which is box, yeah, right? This is the unique pointer in C++. This is the shared pointer in C++. I don't think this is like manual memory management. This is more about logic, in my opinion. Anyway, this does work. Let me show you. Cargo run. It doesn't work because I have written some more code. Source main. I was trying to explain what I want to do. Cargo run. There you go. Look at this. So we have hello world and then x is 4. So so what do we have here? Combined. This is a function that can do login and interact with the file system, right? So we read the file that is called passwords.txt. We log it to the console, and then we do this, which is a little verbose way of specifying the cancel handler, and then we call the simple function. Which is logging hello, logging world, and then canceling. So cancel over here. What this does is it's like return from a function, but it's not returning from the function. It's returning to the closest cancel handler, which is specified over here. So we basically return from this function instead, is what this means. So we return from this function with the value of 4. So we log it out to the terminal. Am I back on NeoVim? That's Helix. No, it's not NeoVim. One day I'm gonna write a blog post on mental overload in languages that are not Rust. Okay, sure. One day I will write my own language and I will write a blog post about a mental overhead on languages that are not my own language, right? Hold on. Do you understand this, Nerdcell, or what? Do you understand this before I move forward? I'm not sure where exactly am I moving, but... I don't know, you got some stuff here. Okay, fine. But won't this thing with the handlers that call functions at some point cause issues with call depths? What exactly is the issues with call depth? How about doing all these things on your own operating system? Before going to your own operating system, we need to make our own text editor, and then before operating system, I think my own window manager, and then maybe. Why do you need an algebraic effect system in Rust? Good question. That's what I'm trying to do today. I'm trying to write it. I'm trying to write a why and everything. Here we go. I was trying to write some words today. What is the effect system at all, right? So one of the things that we can do is we can unwind. One of the things is just tags, like unsafe. Effect system is basically an abstraction over a lot of things that we already have in the language. Unwrap too. Okay. The reason I want this specifically, I think the best way is actually like trying to show this in my game code, right? That's what I was trying to do. We are working on a game. I need to simplify this example and put this into the README there. We are making transitions in the game. Right? So over here, what I want, it's not even effects that I want here. I want to have the continuation objects as a first class thing. So over here, my argument needs to be the continuation of the current function. README. One day we will have documentation. I'm not sure if we will go have documentation one day. I'm trying to write a README, right? But I don't know. I'm having so much trouble. It has been 2.5 hours. I did nothing. Writing README is hard. So I'm going back and forth between trying to write code and trying to do README, and as a result, I'm actually doing like completely nothing today. I just need practice. Yeah, I guess so. Okay. This is game code. This is real code. And I want to do a transition from this into the continuation of the current function. So this doesn't exist, right? Cannot find value, current continuation. So how do I get it? The continuations, we have them. Wait, hold on. So what we need to is like call cc, right? Still, I still want to name this that thing. Maybe. Is that what I want? Hold on. Context. I think I can embed this in the engine for example, engine call current continuation, and then I do this, and then I await. I think this is kind of what I want to see here, maybe. So the reason the call current continuation is a method on the engine, because the engine is acting as an executor for our code, right? So the engine is the thing that knows Does anyone know how to view the best 2D games of this year? From Game Jam Itch. No idea. What does it even mean, the best 2D games of this year? Who determines who is best? There are rankings in Game Jam, no idea. Yet stumble into a good 2D game since 2012. Alright. How about this game? I think this game is pretty good. That's exactly what we are working on here, right? We are working on the full version of this game. And right now we try to think about the effect system so that like we use it in the game. The reason, once again, for us to want the effect system is that I want over here to do this, which means that I want to continue executing current function, like current game state, right? But at the same time, I want to draw the transition. So in order to do this, we call, so like this call CC function. This means call a function with the current continuation. Current continuation is the object that represents the remaining work left to be done by the current function. Or I mean, technically, it's not the function; it's like the current task. And so yeah. So basically, whatever happens after this code is represented as this object that we call CC here, short for current continuation. So we basically pass the rest of the code into a function, which knows how to draw transitions. There you go. So that makes sense now. Why I want this. It's not even like effect system. It's just me working with continuations, I guess. I have reason and realize that ANSI is cringe. Specifically, ANSI escape codes. Huh? Okay. I don't think I will be able to do that for now, though, because the reason is my transition right now as like the reason I want that, by the way, is because right now while rendering the transition, I cannot interact with the game, and I want to be able to interact with the state that I'm transitioning into. I think. And right now, while the transition is happening, I cannot interact with anything. So I think I want to change the definition of this thing. So right now, in order to do transition, I'm transitioning from active state into another active state. Active state is the state that is like that can run forever, which just knows how to draw itself, right? But instead, I want to transition from something that like just knows how to draw it into something that can run and be interacted with. You can open terminal text editor in VS Code, but you can open VS Code But can you open VS Code in terminal text editor? Okay. No, I think I agree. VS Code is better, but I'm just opening Helix here just because I like trying out new things. Okay, so in order for this to work, shit. I'm doing another thing. I'm doing the thing that I was not planning for. I'm so lost right now. I am so lost today. What am I doing? Can someone just tell me what to do? I'm having a hard time here. Do the thing? Alright. Which thing? Okay, how about I just hold on. How about so we just need to structure the things that we have done already, right? Before going forward. Ask ChatGPT to write you a comment. There you go. There you go. I think we need. What I want is to just write down the thing that I have already achieved, right? Which is I implemented this shift reset. Oh, hold on, Nerdsoul. Maybe this is easier, right? Hold on, this is easier. Let me show you this. This is what I did. Before we go into the effects, log on run. Just look at this. So this is our function. So we have this reset. Boom. So we have a function, right? We have a function, boom, which prints begin, and then does a shift. And shift is basically, I think I need to rename it. Let's call this, I think I want to call it still call cc, because this makes more sense to me. So this is me calling a function with current continuation. We have a current continuation, we call it, and then we print hi. So what this means is that the current continuation is the tail of this function, me printing end. So this means that it's going to print this code, it's going to print begin, then it's going to run the current continuation, which is the rest of this function, which is me printing end, and then it's going to print hi. Does this make sense? Because this is a simple example, right? Let's practically differ. Yes. But that's just one, if I just move this, the current continuation, like calling this from before high into like after high, then it would be not a differ, right? If I have it like in between, like two printlns here, right? After. We can have before and after. Right? So I think this makes sense. What is defer? Defer is the keyword that you can see in some programming language, like Go language, for example, has defer. So when you have a function, right, you can write in the very beginning like defer println exit, and this code is going to be executed when you exit this function instead of like right now. What is CTX context? Yes. I guess you know what? If I remember correctly, So the specific terminology that I'm using here, so this was called before shift, right? And this is called reset. This is the terminology that I have like found online. Shift reset. If you just Google for this thing, this tells you to go onto the Wikipedia. This is what we have implemented, the delimited continuations. So this is what it is. This is from scheme programming language. I don't know. Does this wiki page explains this very well though? Can I show the start of the library file in your effects system, please? You can just take a look at the repository if you want to. It's not like I have written any code today, right? Rust effects. There you go. That's what I'm trying to work on. So yeah, the shift reset is kind of nice. So what this means is this implements delimited continuations, which means that I have this object, which is the continuation of the current function as an object, right? So I'm calling a function with current continuation. That is what shift does. So shift is calling the function with the continuation, but the continuation like is not. I think I don't know. Hold on. How do I explain this? How do I explain this? Where is the This gives you example. Where is like the definition? It sprints before, begin, before, and after. Yes. Let's try running this code to make sure that this is what it's going to happen. So I have renamed. Hold on. Cargo run. There you go. It sprints begin, before, and after. Yes. And then this is another example that like is built. So like on top of the delimited continuations, we're trying to implement the effect systems. But I think even just the delimited continuation thing is already very useful. So maybe I should just start simple and just write about that, you know? Because that is already useful, even without the effect system. Just this example. Right? Just lagged out for a couple minutes. All right. What I'm saying is we have implemented like the delimited continuations in Rust, basically. All right. Do you know what it is? And I think this is the first. Since this is the thing that I have implemented, maybe this is what we actually start with writing down about what it is, right? So this is the Wikipedia page about it. Does it actually tell us what is it good? All right, in programming languages, a delimited continuation, partial continuation. This is a slice of the continuation frame that has been reified into a function. This is cursed. What is cursed? Exactly. This code? The continuations? Or what is cursed? There's a reason this exists. That's literally what I want in my game code. Just showed you an example a little earlier. But I need to like write something that explains what it is. And that is hard. That's Let's do this. Shift reset, and not go to the wiki. Instead, go directly to this. Maybe. Is that partial application like in OCaml? Partial application out of the function? No. Partial application, hold on. Partial application of a function is like currying in functional programming language. That's a different thing. I'm not sure. Like what is partial application OCaml? Is that different? Let's define a function as follows: x plus y. Here's a rather similar function. Yes. Yeah, this is just like partially applying the arguments to the function, right? No, that's different. That is different. We are not doing partial arguments. We're doing partial execution. So we're executing part of the function, which is specifically begin, right? And then the remaining part of the function, which is printing end, is being passed as an object to this function. So in this function, this CC, this is a value that represents the remaining part of this function. This is hard AF. That's why I want to write about it. I want to like write it down so that I understand it more myself, and like I want to put it into simple words. But this is a thing that has been existing for a long time in other programming languages, mostly in like research ones. Right? Is Scheme programming language actually used for anything? What is Scheme language used for? Did anyone use this for anything like useful? Scheme programming language is typically used to write text editing programs, analyze and optimize application-based compilers, write drivers for graphics cards, develop operating systems, and many more. Hold on. Huh? Really? Have anyone from chat written an operating system in Scheme before? You can use Scheme to script GIMP, Scheme the system's language. Yeah. So this is what this is from, these things, right? This is from Scheme programming language. Here we go. Shift reset. So yeah, there is a whole zoo of delimited control operations, and it does not seem to be bounded set. GUIL. I'm not sure what GUIL is. GUIL is just like one of the Lisp's languages that also implements this, I guess, right? So interested readers are invited to explore Oleg Kiselyov's wonderful website at this for more information on these operators. Computation. Having an effect. Monads. Lambda calculus. All right. Call CC. There you go. An argument against call CC. This is why call CC is bad. But this is a different call CC that what I think it should be. So like I'm trying to come up with good namings here, because I don't think shift reset that we had before is good naming. So what is a call CC? If you Google for this, call with current continuation. There's also a Wikipedia page about it, right? In the Scheme programming language, the procedure call with current continuation, abbreviated call CC, is used as a control flow operator. It has been adopted by several other programming languages. Monad is just a monoid in the category of the end functors. Yeah, exactly. So that is exactly why we want to say the same thing, but in simpler words, and that is what is hard, right? We're not talking about monads here, though. We're talking about the continuations for now, and then about the effects. All right. Taking function f as its only argument, call ccf within an expression is applied to the current continuation of the expression. Monad is just a nested functor. Yes. For example, call ccfe2 is equivalent to implying f to the current continuation of the expression. The current continuation is given by replacing call ccf by a variable c bounded by a lambda abstraction. So the current continuation is lambda c ce2. Does anyone understand what this is? Does anyone understand this text that is written over here on this Wikipedia page? Does this make sense? You wasn't listening? You can try reading it yourself. All right, just read it yourself and tell me if you understand what this means. So I guess that is why I am having problems here, because like this is what they are explaining it as, but like I don't know. This is I don't know. It's like explaining monad is a monoid, right? Doesn't make any fucking sense. We need to put this into simpler words. Otherwise, it will never become mainstream. What is this? Fact handler, with handler. So over here, Infinite Coder is trying to make what I have, to turn what I have made into syntax that resembles Coco programming language, apparently. With handler, log for log handler, log, yeah, I guess. Yeah. I just never got into that yet. Because I just tried to make it work, and I didn't work on the syntax sugar. I mean, actually, like technically, there is one good thing about, like, I don't like macros too much, but yes. Right now, I think because I'm not using any macros here, it is like it is good. But yeah, can you do the same with for the cancel? Println is a macro. Yeah, that's one of the things that I don't like in Rust. Like, why is such a this thing is a macro? This should not be a macro. You can also do a pull request instead. But you know what? I think since the basic building block is the shift reset, or whatever we should call it, let me just try research this a little bit. I think I'm going to take a little step back. A little step back from the effect systems and go back into shift reset and delimited continuations and just make a crate for it and like write about it without going into the effects. Like, make one thing. You have read about call CC, it's easy kappa. All right, there you go. So Nerdstill saying it's easy kappa means that it's not easy, right? So we want to make it easy, at least like what I have here. I want to explain this in easy words. How do I make it? How do I explain this? Do you like, you have seen this code on the screen for a while? Do you like this makes sense, right? But we need to explain it, and I don't know how to explain it. How to, what is the good words? And one of the questions is the naming here, right? So call with current continuation. That's why this is called call cc or shift reset. And what is exactly different? So current continuation, as far as I understand, by default, is the continuation of the entire program until the very end, right? But delimited continuations is the continuation not until the end of the program, but until the delimiter that you have. And the delimiter that we have in this function specifically is the reset, right? You know what? Maybe let me write this in all in one function. So I actually want all of that to leave like over here, probably. So I'm doing reset, and inside the reset, I have this. Right? Does this make more sense if I just write it in one function? So here we go. Reset. So this gives me the, I think what they call it a prompt in scheme programming language specifically. So like this is what limits my continuation basically. So so this current continuation is the continuation until me exiting this function specifically. All right. Shake my head. Same. Rust is so easy. What I'm doing is not just Rust though. Have you tried though? Oh wait, hold on, Davey. Have you ever tried actually like writing a little bit of Rust code? It is actually easy. I have tried Rust. It is too sassy. But have you? How long have you tried it for, Davey? For 5 minutes? Then you failed and you said no more Rust, right? Am I right? I commented out one of your line. Yeah. Okay. So here we go. So this function, all right, Nerdsel, maybe you can help me. I think Nerdsel is the one that can understand what is happening here at least. So maybe you can help me if you are not doing anything else right now. So reset. This is a function that like limits the thing, limits the continuation, right? So whenever I'm constructing this continuation object, this is basically this object is the remaining parts until this limit, you know, until this limit specifically. So like if I was over here to like print outside, right, this is not going to be captured inside this continuation, you know. So how do we say it? How do we say it? I almost want to like delete my effects here completely. Shift reset is hard to implement. Whatever, it doesn't matter if it's hard to implement. I have already implemented it, right? I want to explain it, not to implement. So let's take a look at some other explanations, right? Shift reset. Delimited continuation. So this is one of the things that we have, this Wikipedia page. Hold on. So Nerdsel, you read about call with current continuation. What about this Wikipedia page? Do you understand this? Let's read this again. A delimited continuation is a slice of a continuation frame that has been reified into a function. I mean, even the word reified, I think, is kind of... Reification is the process by which an abstract idea about a computer program is turned into an explicit data model. So yeah, that's what it means. We basically have the remaining parts of the function as an object that we can like bind to a variable or something. Unlike regular continuations, delimited continuations return a value and thus must be maybe reused and composed. Okay, so basically, reification sounds like the thing on the possible in list and schema and scheme. But I mean, I have implemented this over here, no? Or I mean, what do you mean? We have an example here that is working. Is it possible to create multiple continuations inside one reset? Multiple continuations inside one reset. What does that mean? Create multiple continuations. Well, the function, there's only one continuation, right? Because, I mean, okay, hold on. Inside one reset. I think, like, you can do another reset inside reset. That's what you can do. So, like, let's model one thing. So inside Rust, one of the things that you can have is loops, right? So you have the loop A, right? We already have written this code before. So this is a loop, right? And then you have a loop B, which is another loop, right? So you can write inside your loop. You can break the current loop, which is the closest loop. Or you can break a specific loop. You can break this loop, and you can break that loop, right? So the analogy... This loop never returns, never actually loops, and this is Clippy never loop. Okay, fine. Allow Clippy never loop. Okay, because this is just an example, right? Unreachable. Code. There you go. And also dead code. Whatever. Because this is just an example, right? So how do you write this? Over here. Shift is basically a higher order lambda, and then reset applies this lambda to some expression and returns the result. I don't think that what you said makes it also easy to understand, because I literally didn't understand it. What do you mean, a higher order lambda? What even is a lambda? What is a lambda?
Lambda.
Like a higher order function, but anonymous? I mean, is it anonymous? What is anonymous here? Everything is called, right? Calls is like shift is named shift, right? Or I have renamed it into call CC right now because I'm trying to come up with a name. Closure is lambda. Yeah. I just say that they are functions. That is easier to understand. Just like for JavaScript developers. In JavaScript, everything is a function, right? A lambda, a closure is a function. Just say it's a function. Whatever. JavaScript has lambdas. Well, if inside JavaScript you write a function and you can capture the outer environment of a function, right? So like technically, yes, you can write a function in JavaScript. You can write a function that doesn't have a name, right? So you can have a function return 1, right? Oh no, function statement requires a name. Hold on. Or is it only... void? I don't remember. Arrow functions, you mean? Maybe arrow functions. You get a function without parentheses. Hold on. Why did it say that that my function needs a name? Function. This function statement requires a name, or is this only inside this interpreter? It has been a long time. Expected expression got closing. Maybe it's like this console is not doing it properly. I'm not sure. Maybe what you guys are writing is like TypeScript. Put an expression inside. Should it be this? Oh, this works, yes. So yeah, this is yeah, JavaScript has this. I should no, no. Okay, so we will have this return 1, for example, right? And this is a lambda basically that you can call, and this is going to return 1, right? Anyway, whatever. So like, do you say that this is a function, or do you say that this is a lambda or a closure? I don't know, whatever. I just say function because that's easy. Okay, anyway, what's the case? The use case for call CC? The use case is over here, inside my game. Inside my game. I want to continue running the game, and I want this continuation to be passed into a function that draws the transition, right? That's my use case. So that I can continue play the game while the transition is happening. That's one of the use cases. There's a lot of use cases. Like you can implement effect systems on top of the continuations. Use case for call CC. Maybe we can call CC. Call CC use cases. How do you? I don't quite get it. Call CC is actually much more powerful than C++ try catch. Hold on. What is this? Here's how I think of it, with a couple of examples of use from my own work. As you quickly will realize, I'm not an academic computer scientist, so this explanation might be a bit basic, but I'll let the actual academics fill in the gaps. The basics. In the evaluation of a scheme program, each statement has future, which is everything that will happen once this statement is evaluated. Oh, there you go. Like I think this is easy words, right? So this is what the continuation is, a future. And we are literally using futures because we're implementing this on top of async await. Try catch. Try catch is just one thing. Anyway, try catch, yes. It is more powerful than try catch. The basics. Okay, so we have the future, which is everything that will happen after this statement is executed. For example, in +1, +2, 3, right? This is Lisp. This is like the function that you call, like you add this. So this is basically 2 + 3, and this is 1 + 2 + 3. The statement +2, 3 has a future which looks like +1 xxxx, right? So like after we evaluate 2 and 3, after evaluating 2 + 3, we add the result of that with 1, right? So this is the future. That basically means that we are going to do that after we do add 2 and 3. So this is filling in for the eventual result of this. Since the result of every computation is a single value, we could write the future as a function parameterized over the return value of this, right? So yeah, so basically it means that over here, look at this, we have the lambdas, right? You wanted to call them lambdas, there you go, we have lambdas. So like the last operation that is happening here is we add 1 to the result of this, right? So the result of this is being captured as a value here in this lambda. So we call this lambda value with the result, right? The call CC procedure constructs such a functions explicitly. In a sense, call CC tags a return point in the following sense: +1 call CC lambda return 2 + 1. Return 2 + 1 7. Bad naming here. Hold on, I'm a little lost right now. What are they trying to explain? That is hard. Do I just try to come up with my own words? I mean, I have been trying this for a long time. It's hard. Return 2 plus 1. Just change to f. It's just a variable. Yeah. This is just a name. I mean, you say just change a variable to this, right? Keep uppercase plus ultimate, yeah. Just like, no, I don't think that f is a better name of this variable because this represents what this variable means better. It's just like the fact that they use kebab case with a plus symbol inside the the name of a value is a little weird, right? But this is scheme, so whatever. The call CC procedure constructs such a function explicitly. In a sense, call CC tags a return point in the following sense. Change to whatever, but it's definitely a bad name. Oh wait, hold on. This is a different example. I thought they were writing the same code, but they are actually writing different code here. They are actually writing different code here. Okay. This is different code. Look at the explanation. This is will evaluate 1 plus 1 and 7, which results into 8, and then the plus 2 and 3 never gets evaluated because we have instead supplied 7. This code is different code than this code. So like they're trying to explain it like very weirdly because this, like I would expect them to write this code in terms of call CC, but they are not doing that. They're also doing something in addition, which is like discarding this thing, which is yeah, they got a 7 involved here, so they are returning to the adding 1 with something else with a value of 7, you know. And in this case we are returning to like adding 1 with a value which is the result of evaluating 2 and 3, adding 2 and 3, right? So that's why it was weird to me. That's why this explanation, I don't like it. Examples. Now look at this. One more example of Python generators in Scheme. For example, of using continuations to implement generators. So yeah, I mean, so what all of this means is that this is the basic building block that we can use to implement the effect systems. Oh, you can understand Python generators? Can you link that example? This one? This is implementing Python generators in Scheme. So we implement the generators using the call CC mechanism, right? I can link, of course. So over here, you see, we are defining generator, which is yielding the I, and then we add I plus 1, right? So we are going from 10 to infinity, right? And this is the infinite generator that, like when we call it a once, so like over here, it's doing 10, then 11, then 12, then 13, then 14. And like, because this is not a language construct, this is a library function that can be implemented using call CC, right? So this is the implementation. How do you create the generators using that? So like in Rust, we have a basic building block, which is the generator. So in Rust, async await is being implemented using generators. And the generator is like already a language feature. But instead, if it was some other like thing, which is like working with continuations, then it would be possible to do like more stuff because it's just a more generic approach basically. But I still think that like coming up with with words is very challenging, and that's what we're trying to do here. What are the examples of use cases for continuations? Finally, generally, what are some example use cases for continuations? Continuations are extensively used under the hood to implement other language constructs such as early returns, exception handling, or coroutines. Right? But does like a regular user actually cares about this? If this is just the implementation detail, if you already have exception handling or early returns or coroutines, we already have this in Rust, right? Why do we care? So we need to come up with another example, right? So over here, we are implementing returns, basically. The return can be implemented using the continuations, right? So we define early return n. We are calling, with current continuation, this function. Hello, Picordly. So yeah, this is literally implementing functions and returns using the continuations, right? So return is what? Return is an argument to this lambda, which means that return is the continuation, which is what happens after we call the function, basically. So like over here, basically we're calling a function and we are returning hello rings. So we are calling a function, and when we basically when we call return is we are continuing. You still don't get it? This example, you see, right? Did everyone say hello to Rings yet or no? Hello Rings. How are you doing, Rings? Where do you get the extra control flow? What do you mean, where do you get the extra control flow? So over here, the return. The return, what is this, right? This is just a function, right? Which represents the code after me calling a function, basically, you know? So like return, I get what this code is. Okay. I don't know. Why would you write it like that? And not just inlined. What do you mean? What do you mean inlined? Okay, let's what do you mean inlined? Isn't this code equivalent to? When n is less than 0, square root of n. No, this code is equivalent to basically. So let's rewrite this example specifically in terms of Rust, right? It's a function, right? Function. It doesn't have a name, so let's just call it function foo, right? That takes n as an argument, right? This returns int. So if n is less than 0, then we return -5. Otherwise, we return a square root of n, right? Square root. I guess it's an F32. Is it continuation in C#? Chaining task with continuation tasks. In asynchronous programming, it's common for one asynchronous operation to invoke a second operation on completion. Continuations allow descendant operations to consume the results of the first operation. Traditional continuations have been done using callback methods. In the task parallel library, the same functionality is provided by continuation tasks. Continuation task, also known as just a continuation, is an asynchronous task that is invoked by another task known as the antecedent when the antecedent finishes. Continuations are relatively easy to use but are never less powerful and flexible. For example, you can pass data to the antecedent from the antecedent to the continuation, specify the precise conditions after which the continuation will be invoked or not invoked, cancel an invocation either before it starts or completely if it's running. No, this is not it. So the continuations in C# is completely a different meaning. As far as I understand, continuations is like, so you know, do you know Rust? So in Rust you have futures, right? So task is basically a future in Rust, and continue with is basically the then from is the then. So like it's what happens after this future completes. So the task that that starts working after the current task. So like we finish this task and then we continue with another task. So in terms of Rust futures, it's the then combinator. Then chain on a computation for when a future finishes, passing the result of the future to the provided closure app. So this is the thing. You know what this is. Or if you know JavaScript, I guess. So in JavaScript you have promises and JavaScript promise chain. What is it? What is the function? So you can chain the yeah, it is also called then. So yeah, in JavaScript you also have the then. So I don't know why C# decided to call it this continuations, but it means that like after this promise or this task finishes, you do this thing. So this is the continuation of this promise, right? But it's not the same continuation as what we're like talking about right now. It's a monad. Handle fa1. Hello, hello. How are you doing? We are doing okay, but we are doing nothing for 3 hours today. Like what we're trying to do right now is trying to come up with words to explain what I did before on the previous stream. So we started implementing the effect system in Rust, and I guess the basic building block which we need for that is the delimited continuation. So if you don't know what this is what we're trying to do right now, trying to come up with words to explain it better than it is currently explained everywhere. And I'm not sure if we can come up with a better explanation, because it is hard. And await is this notation in do blocks. Yeah. Yeah. Yeah, exactly. Kind of. But I think like monads is still like harder to like, even although I'm not sure how to explain this stuff that we're doing, I still think that monads are even harder to explain. Like how would you explain a monad to someone who never heard about them? I have no idea, but I imagine it's going to be harder than explaining what we're doing right now. Guardian Cup. Hello, hello, привет. Okay, so what did you say about this specifically? So Nerdsel says that how do I create a new buffer? Creates a new scratch buffer. Oh, there you go. So Nerdsel says that call cc fe is f lambda c ce. All right. Why do you need this if you have future axt? because it's a different thing, what we're trying to do. So can I split helix into two things or no? Can I only have one window here? V split, there you go. Hold on. I want to do horizontal split. And over here, this is going to be the main. Here's the example that you can be looking at. Look at this call over here. This is called call CC, right? So we are calling this function with the current continuation, and this current continuation is the object that represents the remaining part of the program, which is printing out the end. It's like a way to do control flow. It's a little different. It's not just, I don't know. We're literally just trying to explain it right now. Okay, anyway. Nertzel, what were you saying here? Call CCFE is F call CCFE is F lambda C CE. Something is wrong here? Okay. I'm not sure. And do something before awaiting context and after. Yeah. I want to have an object that represents the remaining part of the future. That's what it allows me to do. So like I can reference the future that is currently being executed as an object. So like I'm writing an async function. Async function turns this function into a future, and I want to reference that future from inside the future that I'm running, basically. And that is what this allows us to do. I guess that's one of the ways to explain it, if that makes sense. I don't know. Okay. Hold on, Nertzel. What is your question? What is your question, Nertzel? Function foo. This is what they had written in Lisp, right? This thing. And this is what it, yeah, so like the thing is, we don't want to use the return here because the return is supposed to be a library function and not a language feature, right? So we want to implement the return in terms of my question is, what control flow are you getting from that and how? What do you mean, what control flow? So we get the ability to go back to the caller, right? Which allows us to implement things like return or breaking the loop from like in a more generic way. So one of the other things that like is like going back to the caller is throwing an exception, right? That's one of the other things. So that's one of the things that it allows us to do. The other thing that it allows us to do is after going back to the caller, we can continue doing some code in the callee, right? So this means that after throwing an exception, we can do something and then continue executing the function still. I think it can be done with enumerations. So over here, for example, right? Hold on. So, okay, hold on. Let me do this. Function inner. So this is going to be our inner function. Async function inner, right? And then do you know how futures in Rust work under the hood? Yes. Maybe I need like a better example than this. Like if you don't understand what this allows you to do, that means that this is a bad example, right? It allows us to implement the effect systems, you know? Effect handler. Does algebraic effect is what you want? Yes, we are implementing algebraic effects on top of this. Like, this is the building blocks. The building block that allows us to do the algebraic effect. This example is identical to sequential example statements, just with a defer to after. Yes. But we don't have defer in Rust, right? And I mean, this is, I don't know, this is more generic. Okay, this is hard. What is your question? Like, this specific example is not good, right? We need to come up with a good example. But is this example good? Like, from the real use case. I'm making a game. And I want to have the current continuation. So like, I'm currently playing a game, right? And then I have drawn I did something, I don't know, I showed a menu or a settings screen. And then after going back from the settings screen into back into playing the game, I want to draw the transition. In order to draw the transition, I want to have this object that represents me playing the game as an argument, and I want to have like a way to draw this like settings menu as another argument, and I compose them together. You know, I compose together the continuation of the current function, which is me continuing to play the game, and the like the way to like do something. You know, that is what it allows me to do. Is this a good example? I just think this example is too complex, though. No, does this make sense? As an idea, yes. So maybe I need to, like, instead of making this inside the real game, like, put this example as an example in the repository. So, like, try to implement that. Like, let's say that we have a terminal-based game, right? We have a terminal-based game. Maybe let's do this, right? Exactly. Let's make a real use case for it. Implement a terminal-based game. Right? I don't know. I don't want the example to be too complex. They're also struggling with scheme syntax. It's just Lisp, though. What is, like, I don't know. Whatever. Oh, 3 hours doing nothing. I'm amazed at what we can do sometimes. I don't think that Rust is a suitable language for it. We have a rich type system, and I don't think that's possible to implement without compiler support. I have already implemented that, though. This example is working. This is I mean, this probably is not a very good example. So, is it convenient? It is convenient enough for me. Especially since my code is already async await, the fact that I'm adding async and await here for everything is, I'm not going to even notice it. So it is going to be very convenient for myself, yes. Even if it's, like, I don't need a new language for that. But yes, if this was a language feature. So what I'm doing is I'm trying to implement effects on top of async await, but it should be the other way around, right? The async await should be implemented on top of the effect stuff. Hold on. There you go, guys. I actually have There you go. I made the meme. I think implement your own future may be solution. What do you mean? Let's go zig. No, I don't want to go zig. I want the things that Rust has, which is the ownership system and other stuff. So this example is working. Begin, before, and after, right? Implement future trait for your genetic context. So we basically want to implement async await using my stuff, using which is using async await. So we're going to implement async await using async await basically. That's what you want me to do. All right, let's try. I need to go deeper, and then we implement async await again using that. I mean, I think I want right now to limit it to just this delimited continuations library. Actually, because of like, yeah, it looks like it's kind of complex. I want this small building block to be ready first, which is just the call CC, and then we implement the effects on top of that. And then on top of that, we implement async await. And then we implement move only compiler. So if you want to implement a future using this, right? What is a move only compiler? Yeah, I have no idea either. So like custom, like async using call CC, right? Whatever. So this is going to be a function where so we do this context call CC. No. Context. Hold on. What is a good example for async? What are we trying to implement then? Sync example. Like just a timeout? Timeout is like, can we have any other example? No. I don't know. I can probably take a look at Tokyo Select macro. All right. Why? Why would I look there? Because what? Okay. I'm looking at it. Now what? It does stuff before and after. What do you mean? No, select is selecting the future that is going to resolve first, right? So like we're trying multiple, we're basically running multiple things at the same time. And whichever basically ends working first is being handled. That's what the select is, right? Unless this is different. Is this in Tokyo different from like futures select? So this is the simpler version of it, which is just selects two futures. So you run in two futures, and then whichever returns first is this. Like, okay, why do you want me to look at this? Does this have what does it have to do what I'm doing? I don't think I want to implement async using my stuff right now. Once again, we're stuck doing nothing. Okay. A better example, I guess. Okay. So we have a real world example, but this example is too complex. So I need to like minify this. I think that is okay because I don't think I can come up with another one right now. Show reset function, please. You can take a look at the source code if you want. This lives on my GitHub. Like go source shift reset, right? So this is implemented. I'm basically running my own executor here for the futures. You want the implementation of the reset function? It creates the reset executor and runs the executor, right? So I'm polling my futures manually here. Okay. We want to come up with a good example and then a good explanation, right? Apparently this example is not good enough. How about this? Hold on. How about literally the thing that I was trying to do? In the game, but I don't want to have any graphics here, right? Is the problem. So I want it to be simpler. If I do a terminal-based game, is there like the analogy of the transition? So for example, you're making a terminal-based game. You are like a text adventure, right? You are in a dungeon. You say, enter the cave, and you want to draw the transition in the terminal. What is the drawing the transition in terminal mean, though? I can just literally just draw some dots, right? You know, like I can just have this animation, which is like making more dots, right? And this is basically our transition. And like we want basically at the same time as this is being drawn to like continue playing the game. So we can basically input our next action while this is happening. This is like the use case that I have. So we have a function game, right? So we are in a loop here. We do like next action is read line, right? and then we match next action, a string, for example. Function read line turns a string. We match, like, we go deeper. Okay, how about we call this, like, this is an infinite dungeon, right? This is like the same example as I have in my game engine. The triangles, you're actually confused. I am actually also confused right now. That's why we have no progress in the last 4 hours, right? So I'm trying to get unconfused. Deeper. Do you understand the first example in the CallCC wiki page? This one? This example? As shown in the next example, CallCC can be used to emulate a function of the return statement known to C-style languages, which is missing from scheme. Define f return 2 3. Return 2 3. Okay. Fine. I will tell you what it means, right? So it's because you are unfamiliar with this language, right? So what is written there is you have define. So okay, let me just copy this here. So you have define, and this is the brackets, right? So literally the outer list is the thing that is having define in it, right? And then you have f return. Then you have this. Oh shit. And then you have 3, right? And then you close it, right? So this is actually, I read it as f return is return 2 3. Yes. So instead, what you need to do is like, so this is the body of the function. What is this? What is this? Okay. So this is the keyword basically that allows you to define a function. This is the name of the function, and return is the argument of the function basically, right? And this is the body of the function, and the body of the function is the 2 statements. The first statement is return 2, and the second statement is, what is happening here? Okay, so the first statement is return 2, the second statement is 3. So it's not return 2 3. It's return 2 basically comma 3. So these are like the list of statements here, because when you're defining a function in this language, so this is the signature of the function, and all of the remaining arguments are the body of the function. Where imperative what? Imperative without semicolon? Yeah. Kind of. It is a little confusing. So like the alternative in Rust is like you can function f where return is an argument, right? And is the body of the function. The first thing is return 2, and the second one is 3. So this is what it means. This is what it translates into. So return is just an argument to this function, right? And then when you call it here, you call this function with lambda xx, which is basically the identity function, right? So whenever you are returning something that's actually unreadable, well, yeah, I don't like this syntax, but you are just not used to it. I think it just requires a little bit of getting used to understand, but yeah, maybe I do agree. Rust syntax is better. Okay. Let me come up with a good example. Maybe like you will like this one more. So So I want to have a game that has like 2 instructions in it, which is like going deeper into a deeper dungeon, so like to the next floor, and then exit to exit this, right? This is just like the example of my game engine where we have the triangle. So exit. Exit means return. No, like, what the fuck? It looks pure FP, but it's imperative. It doesn't make sense. It's like a do notation. Like, you can think about it as like the do notation. Right? No? Maybe? Potentially. Haskell also looks imperative sometimes if you do the do notation, right? There are no variables. What do you mean? The variable is return. Return is a variable. This is not a keyword. The f is a variable, which you bind this lambda that takes a return as an argument to the f, right? So you can call this with the arguments, and the arguments to this function are these two. Are this one? You only have one argument to this, which is the lambda. What is this? Not a variable? Or what do you mean? No variables? No mutable variables? Whatever. Do you understand the syntax now at least? Okay, so here we go. Here's the example, which is almost like exactly my game code, right? So when we press the button to go deeper, we just call this function recursively, right? Dungeon. We just call this function recursively. This is an async function, so we just need to do something like async recursion. Cargo add async recursion. I'm lagging, by the way. I don't know if you said anything. Well, I'm just trying to come up with example. Like, just look at this code that I'm writing, and if this makes sense as a good example of what I'm trying to do. So right now it's nothing but just a recursive function, right? So we are making a game, a dungeon, like, and dungeon gain, where in every on every floor we can go deeper into the dungeon, or we can like I guess not exit. So far, so async, yes. So, or we can go back. So we like go back to the previous room where we were, you know? And so going back is just like returning. So yeah, like when we are going deeper into the dungeon, eventually we will return back, right? So this is kind of what my game code actually looks like right now. And what we want is to add some like animation on top of that, right? So let's see, depth, println, you have now entered depth, for example, right? Dungeon. So when we're going deeper, we are increasing the depth. Depth plus 1. This is simple, right? So why do we need the this thing? Why do we need this thing? It's because when we are exiting the dungeon, we are going to execute the remaining part of this, which is like reading out the next instructions. I think like in order to make this more I just I don't want the user to interact with the command line. So read line is like going to be instead like the next instruction. Like next action. Next action. Right? Let's do this. Next action. Function next action. Action. Enum action. Deeper or going back. Right? These are the two actions that we want. Let's not even interact with the console. Oh, look, a good example for a linear effect right there. Yeah, so next action is also an effect, right? So yeah. So linear effect, like I was saying, is just an argument, right? So like actions is going to be mutable actions, you know? Mute impl actions, something like this. Trait actions, function, next. You might have broken chat, everyone left. It's okay. Everyone stops understanding what is happening, and like including us ourselves. It's alright. It's alright. I guess actions is literally, so this is just the iterator. Mute impl iterator. You know, where item is action. I think this is it. So this is kind of a linear effect, but we can just do this thing, right? So next action is literally this. Match actions next, right? Some action deeper, then we do this, then if we do some action back or none, we return. Right? And we pass the same actions here. Is this good? Is this a good example, right? Okay, so we have actions. These are the actions that are going to be performed by the user. We can take them from the from the std in, but in order for this to be an example, I'm just going to construct the actions that we're going to perform. And we want to have the animation, because I don't know, like if I can come up with the example that is not like showing something on the screen, because that's what I'm trying to do myself. I have a general question about the async recursion. Is tail call optimization possible in a core routine? If so, do you know if C++20 core routines do this? Does LLVM and GCC optimize this kind of recursion calls? If you're talking about specifically async recursion, then this means that this function returns a boxed future. That's what it means. I don't think Rust at least is doing tail call optimizations. I don't really know. I don't care that much, so I didn't. If you have regular functions in Rust like foo, and this function calls goo, then this is a tail call. So does this is this being optimized? I mean, probably it does, right? But async functions are different because they are being transformed into the future objects. So it's like it's a different thing. I'm not sure about that thing. But when we're doing async recursion, this requires this macro, because to do async recursion, we need to do boxing. So this actually allocates when we're calling this function. So I don't think that like, at least for this code, there is not going to be so even although this is like, if I do like return this await, right? This means that I'm going to this basically is a tail call. This is not going to be optimized, I'm pretty sure. Okay, let's call this function enter dungeon. Enter. I don't know. We can call this just enter dungeon, whatever. You have now entered depth this. Right? Instead of return, let's do break, and in the end we do print line. You have now exited depth. This could have been written as a while let. Yes. How about a fix? Replace match with an if let. Okay, so then we do while let. There you go. While let. There you go. Look how simple this function is now, right? So we just so yeah, if we want to go deeper, we go deeper. Otherwise, we stop. That's it. Easy, right? So now what I want here is I want to call with current continuation here in order to draw. So like when we're going deeper, I want to draw the animation of us going deeper, right? Or what? But it's still, hold on. For this specific use case, it doesn't make sense because, hold on. Or maybe it still does. Hold on. Let's just do this. Function transition, right? So we are going to draw the transition just like I'm doing it in the game, right? I am transitioning into something, which is a future. And I'm going to do showing transition, right? And then I do into, oh wait, so this is like the easiest thing that I can do, I think. So we are transitioning into like some other stuff that is going to happen, right? So when we are entering the deeper dungeon, when we're going deeper, right? We are basically transitioning over there, right? And then after we exit, we transition into the current continuation. Does that make sense? So in order to do the current continuation, we do we call with current continuation with a transition. Does that make sense? So this means that I need the context. Well, I guess this doesn't work. All right. So we have found a problem, actually. because we're moving it. So right now, this library only allows calling the current continuation once, which actually makes sense. But can I allow it to do it multiple times? Okay, hold on. Let's finish working on the example, though. Does this make sense? Does this example make sense? Nerdsel, are you here? Do you like this example? This is literally what I want to write in my game code, right? So if we try to go deeper, then we are going deeper with the transition. And then when we're going back into our, like, what is remaining to do with the transition too, right? So this means CC transition CC, like this, right? What? Does it make sense? We are doing the recursive dungeons, right? So if I'm going deeper, then I'm calling this function recursively, but at the same time as I'm going deeper, I want to draw a transition, right? And then when I'm going back from the deeper level, back up, then I want to also draw the transition, but in order to draw the transition, I need to provide as an argument the continuation of the current function, which is me continuing playing, basically. Does that make sense? Or is that still a bad example? I think this is still not a very good example. Or is it? You kind of get it, but you don't? So yeah, show in transition. This is like the visual effect that is going to happen, right? Showing the transition. This is like the visual effect that I want to show here inside my actual game. And then, like, right now I'm showing the transition and then I'm running the whatever I'm transitioning into, right? But what I want to do in the actual game, I want to show the transition and run the remaining part of the game at the same time. So I'm going to do in the actual game code, I'm going to do like futures join, probably the so like the transition itself. So transition itself is an async, like stuff itself, which like showing transition, right? So this is the transition, and this is that thing, and I'm just doing futures join transition and the thing that I'm transitioning into. So I'm going to draw the transition and play the game at the same time, basically. Let me finish understanding call CC. Isn't it like useful to have an example for the use case of call CC so that like actually it's probably not going to be join, it's going to be select. No, it's not going to be joined. Yeah, it's actually it's weird because like when the transition is happening, I want to like the transition and the remaining part of the game to happen at the same time. And once the transition exits, I want to only the tail to be happening. If I want to be looking like exactly like the code that I'm going to write eventually, then we do futures select actually select. So so we have nothing. And then into sure, but I need to understand more than just an example. You want to understand how it works already? Or what? Because callcc is technically the implementation detail, right? Or, I mean, it's not the implementation detail because I'm using it here in this example, right? I don't think I can do what I want to do with the macro. We need to do futures. Future select. So I'm going to select from the transition. And this thing. I'm going to wait. We're going to match. Right? Can you? Why does the? Okay, there you go. Change visibility. Hold on. Why does Helix not want to? Where am I supposed to like hover so that the Helix wants to like fill the match arms for me? Missing match arm is what it says. So like, how do I make Helix inside the brackets? Oh, okay. Like here, there's no code actions available, is what it says. It would have worked in VS Code. So why is it not working in Helix? Or is it because I forgot to fuse them? Because I need to fuse my futures too. Maybe that's why. Let's import futures prelude. Fill my charms. Now I can fill my charms. All right. I'm pretty sure that in VS Code, it would be able to do this even without it. I remember I have seen an option in NeoVim to select an action for the selected line or the selected symbol. All right. Okay, so left. Left is when the transition is finishing first. So this and that, and this is when the other thing does. So the transition has not finished yet, but the future has already been finished, right? So in that case, for example, I don't want to show the remaining part of the transition. We're just going to do value, and over here, I'm just going to do into await. My charms have incompatible types. Um, oh, because it's the other way around. Value and transition. So this is the actual code that I'm going to have inside the game. So I'm ignoring this manually here because what this means is that don't show the rest of transition. It's on symbol in Helix. I don't know if there's an option for that. Code actions. Code action. Yeah, code action is only like one command in Helix, I think. What it looks like. Where is the pin macro? Is it in the pin utils or is it in std at this point? I'm not sure. Macro pin. Oh, it is in std. Nice. Hello, Ricky. Consider using the pin macro. Did I not use the pin macro? I know it's been everything. I don't remember what it means. That's why you don't want to do async Rust. The error messages are bad. Hold on. Async block cannot be unpinned. That's okay. The block is like the async block that I have written there. Created unpin is not implemented for this. Did I? Isn't this macro? Should I do LED transition? Oh, okay. I guess the last macro that I used was not from the std pin. It was from the pin utils, which like introduced the binding itself. Right, there you go. Oh, and because I have lifetimes now, that did async recursion is not too is not smart enough to do recursive things. Okay. You know what? Let's not do it with the recursion. Let's do something simpler. Let's do something simpler. Dungeon. I mean, I don't know. It's going to be called game, for example. You know, we are going to transition not into playing the game. We're going to transition into like like, I mean, in my use case, it's actually going to be async. It's just going to be it's going to be recursive. It's just like the bad example because this macro is not good enough. Consider adding the following bound: a async recursion. Yes. So we need to like expand this macro manually. So we're going to write async function enter. My sprinkler goes like this and then comes back like, all right. Hello there. How are you doing? Enter impl. And then so enter impl is the async function that is going to call impl enter, and enter is the just the function. That returns boxed future. In local box future is what we return here. We do enter simple. Okay. So now we only have the moved problem. All right. Okay. Well, my actual transition will go is going to be even more complex with that, because over here I'm just printing showing the transition, right? But it's going to like do more than just that. But this is very close to my actual game code. Okay, so I guess I need to fix this. So right now, the this reset function provides me with the context, which I can use to do the shift or call CC only once, because this takes self by value instead of taking it by reference, right? Can I make it so that I don't take it by... So what does it mean? Calling this function multiple times. What does it mean? So this means that this should not be async one shot. We just do regular, like async channel, whatever, something. Let's see. Async channel. So what is wrong right now? My Helix does not show the fact that it's still loading or something. I have added a new crate. What should I do right now? Like restart my language server? Okay, there you go. Now it works. Why do I need to restart my language server all the time? Like in VS Code, I never have to do it. And this is the problem with both Vim and Helix. I need to restart my language server. I mean, I added the crate, right? And I expected it to, like, do whatever it needs to. Some VS Code magic. Well, it means that VS Code works and Helix or Vim doesn't. Right? For whatever reason. Like, do you always restart your language server when you add a new crate too? Maybe VS Code restarts automatically when it sees changes in the TOML. For example, the dependencies have changed, so you need to restart your language server. Not really a problem for you? Okay. I mean, it's not a very big problem. Okay, so we over here, we do async channel bounded. Should this be bounded? I think it should be bounded. It should be bounded by 1, actually. It's kind of like one shot. Hold on, what does bounded even mean? Creates a bounded channel. The created channel has space to hold at most cap messages at time. Capacity must be a positive number. Yeah, it's going to be 1. Okay, so when we are receiving, over here, async channel receiver error. Received because the channel is empty and closed. No, it should be a try receive error. Try received error because it's empty, specifically. If it's closed, yeah, we want to specifically handle the empty case. In the empty case, we just do nothing. If it's closed, for now it's unreachable. Okay. So we don't need to redo this. Remove this mute. And then here, so we are sending into the sender, right? I think we... Is there a function that's called try send? There is. Attempts to send a message into this channel, okay. And then we just expect and panic. Alright, for now. Okay, so now, basically what this means is that I can call with the current continuation multiple times, right? Which means that this does not necessarily need to take self by value. Sender is this. Yes, we do self sender, right? We take, so in order to do sender send, we take self by a regular reference. Okay. Can I do regular reference to self then? Probably. So reset handler. This takes self by reference like that. Okay, so when we have here, we have a reference to the reset handler, I think. Is what this means, right? This is our previous example. Let's comment this out for now. I think this example is still simpler, but I don't know. I mean, it is simpler for sure. So right now the problem is with the actions. We have a mutable reference to the iterator. And find function run. And borrow actions as mutable more than once at a time. Can borrow actions as mutable more than once at a time. First mutable borrow occurs here. Argument requires that actions is borrowed for 1. It was borrowed here in the previous iteration. Yeah. It's because we have a loop. Because we have a loop here. But why? Because once I exit transition, what if I just call enter without calling transition? Then it's going to work, right? No, it's not. Why not? What if I change the dynamic iterator? Is the error message going to be same? Yes, I can borrow actions immutable more than once at a time. Actions were previously borrowed here in the previous iteration of the loop. It's because the lifetimes on this function are wrong, right? Recent handler, shift arg. Okay, it's just like the lifetimes were wrong here. Redundant closure makes self sense. So that's it. Let underscore future allow clippy let underscore future. Why don't I even see this here in the auto completion? This warning. Okay, there you go. So this is a complex function that I'm not sure if, like, for the sake of the example, does it make sense to make this this hard? All right, whatever. Let's try running this, right? Let's try running this. Is it even going to work? So I'm going to block on, and the function is going to be reset. So this provides me with a prompt, and then so we have this context, which we'll probably need to come up with a better name for, and we do enter. The context actions are going to be no, action deeper, action deeper, action back, action deeper. So let's say that our player is doing 4 actions. It's going deeper twice, then going back, then going deeper, and then nothing. So nothing means that we are going to return completely from this function. Nothing is like the same as going back automatically, basically. All right, and then as the last, we start at the depth of the 0 of this, right? Oh, okay. Async. Oh, wait. Async move specifically is what we need here. Okay, so here we go. Algebraic effect, game effects in Ging. Yes, that's what I'm trying to do. Like, I'm trying to like provide a minimal example of a use case. I'm actually like I'm back from working with effects and I'm doing delimited continuations. Are you familiar with that thing? I'm trying to minimize this. I'm not work on the first time heard. Okay, I thought you were like looking into different programming languages and stuff. Whenever I research this, this is always gets me the Scheme programming language. Basically, are you familiar with Scheme? Because that's what it is from, I guess, originally. Maybe you look at me looking at other programming languages and getting inspired. Just wait until we make our own programming language. I'm having trouble today though. Like I didn't do much. What I wanted to do today is to like document this, but it's not going very well right now. Like I'm trying right now to come up with a good example to explain what I'm actually doing. So like you have never heard about it, right? So how do I explain this thing to you? That is hard. That is a challenge that I'm trying to solve today, and it's not going like very well. I don't think I have come closer to understanding how to explain this to other people. So I don't know, I'm just playing around with it, trying to come up with an example. So here it is. Here's the minimal example of what I'm trying to do in my game actually. So like what is my real world use case for this thing that I'm implementing here, right? I'm playing a game and I want to draw transitions in my game, right? So this is the simplest example. I'm entering the dungeon, and when the player presses a button to go deeper, we go deeper. And then when we return from this function, we're back in like the current room. And so when going from the deeper dungeon back, I want to show the transition. And when going into here, I also want to draw the transition. So that's what I'm going to do also here. So I'm doing two transitions when I'm entering the dungeon and when I'm exiting the dungeon, basically. So in order to draw the transition when I'm exiting the dungeon, though, I need an object which represents the continuation of the current function. So like I want to know what I want to have the remaining part that is like left, the remaining work that is left to be done by the current function as a first class object. So that's what we have implemented actually. So that's what this call cc is all about. This means call the function with the current continuation. And this is what it's all about. I don't know. Did I explain anything that makes sense? Did it make a little bit of sense, what I just said? I have no idea. Let me try running this. Probably makes a lot of sense. Probably. Probably means like if... Okay, so let's see what happens here. You have now entered a depth 0, showing transition. And then we have entered depth 1, so we are showing transition. And then we have entered depth 2 after we have entered depth 2. You know what is missing from this? Let's make this iterator over here that I'm doing with my with my actions. I'm going to inspect this iterator, right? Action. I'm just going to say print line performing the action, something like this. No, performing the action. Let's derive debug for this. Derive debug. There you go. Argo run. Okay, so there you go. So we have entered the depth number 0. We are performing the action that is called deeper, right? So we are showing the transition and entering depth 1. And we are performing deeper, so we're showing the transition and entering depth 2. And we are performing the action back, so we have exited depth 2. So in between, so yeah, we have exited depth 2, we're showing the transition. This is the transition of us going back from depth 2 into depth 1. So I guess what is left to do in this example specifically is maybe over here. One needs to know a lot, like the continuation and what's the runtime behavior when the code is run. Yes, so I want to try to come up with the good words that like explain this, because I think this Wikipedia page does not explain it very well. Like in order to understand this wiki page, you need to understand a lot, right? But I think this is actually kind of simple. So this should be it should be possible to explain this in simple terms, right? Like specifically the continuation, what it is like the tail of the function. So like I'm right now here, right? Or over here, right? I'm calling with the current continuation. So like this function is going to be called with an object which represents the like the remaining work left to be done by this function. So like the remaining like the rest of this let loop, and then eventually printing that we have exited, basically. Kind of. Transition. I think I need another lock here. So like when we have exited, right? Yeah, so over here I want to print now back to depth, right? Maybe just to understand what is happening in this example even more. So we are in depth 0, we are performing deeper, we are doing the transition into the depth 1, we are performing deeper, we are showing the transition into the depth 2, we are going back, we have exited depth 1, back to depth, from depth 2, we went back to depth 1, showing the transition, going deeper, showing transition to go deeper, going to depth 2, exit depth 2, back to depth 1. You think you get it now? So does this mean that this example is actually good? If you get it now, or what? Anyway, this example doesn't finish for some reason. But if I do, then you are doing a different thing. What exactly are you saying? That I'm doing a different thing? What do you mean I'm doing a different thing? I think I get it, Davey. I think you forgot the kappa. But do you actually get it? We want to use it for link cider, Davey. That's why I'm doing it. If not, like just the puzzles are enough. So like here's approximately the same, but without 70 lines of code. No higher order concepts, just recursive function. Yes, sure. I mean, yes. You are. Okay. Good job. I guess, okay, fine. I guess this example is not good because my transition is literally just printing a function. In my actual game, the transition is not just printing. The transition is doing something at the same time that the game is going to be played. So when I go deeper into the dungeon, right? And then I go back, I want to continue playing the game, but at the same time I draw the visual effect, which is like cross-fading or whatever else, right? So it's not as simple as just printing something onto the screen. Maybe in order to make this more, I need to like draw an actual spinner here. So that I don't know. Like I'm trying to come up with the example that is not too complex. So like obviously I don't want to have the entire game engine for the sake of this example, right? So it's like an async, no? Oh my god. No, it's not. What about this example, Heat? Maybe it's going to make sense to you. What about this example? This is another one that I had before. Right? So what this example does, this is much shorter example, right? But we have this reset and call CC stuff. So this means we are going to print begin, and then this is calling a function with the current continuation, CC, right? CC is the current continuation. This is the continuation of the current function, which basically means that this this operation, CC, is printing end. Because this is what is the continuation of the current function, right? It's what is like left to be done. This is printing end. So CC await means printing end, basically, in this example specifically. So with this this program is going to print begin, then it's going to print before, then it's going to print end, and then it's going to print after. So basically when the function passed to call CC calls the CC, the call CC gets replaced with by the argument passed from the function. No. What do you mean call CC gets replaced? By the call CC gets replaced by the argument passed from the function. If you look at the return example. Which one? This one? Is it on the wiki? Oh, I guess it's in the regular call with CC. This one, right? Okay, is the benefit of CC to be able to reorder the effects? Yes, it's kind of reordering, right? It's like async await. Async await is literally like you are allowed to. So like when you do await, it means that your function is not going to continue is not going to continue executing immediately, right? It means that whatever the executor is doing, like your function is going to be reordered. The execution, right? It's a way of doing control flow, basically. Yes. And using this operation, using call CC, you can implement a lot of things using that, which are already. And the benefit of CC in game programming would be to have things moving, but other things would know to wait until animation has played in full before they continue. Would be have things moving, but other things would know to wait until animation played in full before they continue. By the way, call CC means use C compiler. Plus, it is so messed up. This is the this is my own naming of this. I mean, this naming was like from this wiki page. Well, with current continuation, it's called call CC. Okay, hold on. What are you saying? In this one, so here call CCF. This call CCF is being replaced with 2. Call with current continuation F. Huh? Thanks for the raid, Infinite Coder. How did your stream go? And then in the limited continuation, an example with lists. Example with lists. Which one? List stream, this one. We can generalize this and convert lists to stream in one fell swoop. Define a list stream. Is this the example? Rust is so messed up. It leads otherwise wise and capable developers to the dark side and invent names that like call CC without any nuclear tension. All right. Rust, like I have heard other people saying that Rust is like the gateway drug to Haskell, but I think for me, what it ended up being is like the gateway drug to like go into all of this like type theory, and eventually we're going to invent our own programming language probably. Yeah, probably. I don't think I want to do Haskell actually. Haskell has some limits too. This is a good read for you for today. All right, let's see what it is. Leaving Haskell behind for almost a complete decade, starting with discovery of Haskell about 2009 and right up till switching job where I used primarily Ruby and C++. So what are you leaving it for? Are you just doing nothing now? You like that's another like solution to all the problems that we're having. We can just quit programming altogether. You know, leaving Haskell behind. Is that what they did, or did they switch languages actually? Hold on. What if we do Control F Rust? There is a couple of Rust. Mostly Rust for him from now on, I guess. I have like Haskell. I have looked into it for like a very long time. I never have written a proper like application. I never have written a game in Haskell, but I have been reading a lot about the language. Like I know one of the things that they added recently is the linear types, and that's something that we don't have in Rust. We have affine types in Rust, you know. So like linear types is another thing that I want to have in the language technically, as well as like effects. Some people think they want monads, but I think effect system is better. Ganglang and gang script. Yes, but I think the language that I want needs to be both scripted and compiled. So like it is going to be both. It's going to be the same thing. When I. Anyway, I'm not. Nurtle, what is your question? You asked something. The list example over here. What did you want? Reset shift. They have shift reset, right? That's what I would do. Like call CC. This was called shift before, because that's what they use here. I just don't like the naming shift and reset. This doesn't make sense to me. Why is this called shift reset? Can anyone tell me? No idea. Did you get the return thing? Can you repeat your question, because I'm not sure what you're asking. What do you think about the lang of the day? From what is this? Hold on. Let me talk with Nerdsoul. Call CCF is literally replaced with 2. It's not replaced with 2. It's been evaluated to 2. It's like saying, I don't know, calling function sum on the list 1, 2, 3 is being replaced by 6. It's not the same. Right? It's not being replaced. It's being evaluated to 2, right? Or, hold on. Are you talking about this example? All with current continuation F. So this returns 2. Yeah, so we're calling F. So yeah, this lambda x, this is the current continuation, right? And since our first operation is returning 2, so we're calling our current continuation with with x and current, yes. So yeah, so, and the current continuation, because this is the interpreter basically, the continuation is just nothing. Because yeah, and because it's nothing, we just get 2. So see, there is nothing, yeah. So like the continuation is just nothing, so you just get the value that like you passed. Yeah, it's just being replaced. It's not being replaced. The continuation is being called with 2, right? It's not just like, what do you mean by replacing? Anyway, all right. What is this, Davy? What do you mean? You're pooping, but you also want to pee? What? You are trying to explain yourself, and you are not being very, and you're not explaining it very well. Just like I'm trying to explain this thing, and I'm not doing very well. Did you see this implementation and examples of the Rust algebraic effects? Yes, when we were implementing this on the last stream, we were referring to this. Yes, so this library is already doing effects in Rust. This is using nightly Rust and using generators to implement it. But what I'm doing is I'm doing kind of similar thing, but I'm implementing it using async await. So like, you know, like in Rust, async await is being implemented using generators, but I think I also have seen a crate somewhere where generators in Rust, in stable Rust, can be used, and they are implemented on top of async await. Like you can go the other way around too, right? So that's what I'm doing. I'm using async await to implement the effect library, which makes it possible to use it on stable Rust. And this library only works on nightly Rust. There is another one which is called F, I think, just F, maybe. Maybe. Effective Rust, algebraic effects library for Rust. This is another one. So there is the F in med, and there is this one. The idea of implementing algebraic effects via coroutines by F Lua. Hold on. Is one shot algebraic effects for Lua. Maybe is if Icy Lava is here. Maybe Icy Lava can understand this by this Lua stuff, because Icy Lava is doing Lua. Whatever. The example so far wasn't hugely convincing. If a simpler thing does the same thing but clearly better, there needs to be a huge payback for the added complexity. There might be. Well, it's like I have no idea how to make it simpler. The thing that I want to do in the game code, I have no idea how to make it simpler. Give me, like, how would you write it, right? So this specific example, like I said, the problem is like not exactly as the game code that I'm writing, because my transition is not just printing something once, right? It's like it's showing the transition over time, right? It's not an immediate thing. So maybe I can modify this example a little bit. Not just printing, yes, it's pooping. Ha! What are you saying? What are you trying to say, Davey? Is Ricky watching the stream and also trying to understand, or like, hello, Ricky? Something about your example being spot on. The visceral feeling, how hard is it to pause pooping to get to wait finish peeing? Oh wait, hold on. Is there actually an example of doing pooping and peeing at the same time? Kind of, right? The transition. Hold on. What did Davey actually say? No, but I can tell Davey gets it. Alright, maybe Davey actually gets it. All right. No, let's make an example that doesn't use pooping and peeing in it. All right. Hold on, and let me also see, like, why is it now back to depth 1? Like, what is happening then? Now back to depth 1. So we are back to depth 1, and we are calling the transition, and it's never happening. So shift shifts the execution back to reset, with the shift call being replaced by a lambda. What do you mean shift call being replaced? I have no idea what do you mean when you say something is being replaced. Yes, we are shift means we shift the execution back to reset. And then the reset can potentially make the execution go back into where the shift was called. Quite literally replaced actually. Okay. Okay, so you say that this is still shift. Okay, let's rename this back to shift, right? Because that's what they use. Read the list example. Okay, let's read the list example. Which one? Which one of these examples is the list example? This one? Or this one? The one with cons. There's multiple examples with cons. This. Let's take a more complicated example. Let null be the empty list. So we reset, begin, shift, k, cons 1, k void. Context captured by shift is begin star null, where star is the hole where the case parameter will be injected. The first call of k inside shift evaluates to this context. With void replacing the hole. So the value of k void is begin void null, which is null. The body of shift, namely cons 1 null, is 1. Becomes the overall value of the reset expression as the final result. Making this example more complicated, add a line. This. If we comment out the first shift, we already know the result, it's 2. So I can as well rewrite the expression like this. So we are doing cons 1 and list 2. So this is list 1 too. Alright. What is your question? Okay. I still think this is a little confusing, but okay. My browser needs dark mode. Dark mode Firefox. Okay. Confirming that you understand it correctly. I don't know, I didn't read through the Wikipedia page. I was just working on my own thing. This dark mode looks ugly though. I don't know. I'm okay with it being light mode. Maybe Wikipedia can be have in a dark mode. Is there such a thing? Try Dark Reader if you want. Dark Reader. This is for Chrome. Dark Reader, Firefox. I don't know. What is this? This is not too bad. This green looking weird. Anyway. Keep you hearing Wikipedia. Oh, look at this. Cooperative multitasking using call with current continuation in 25 lines of sim. So this is implementing async await using using call CC basically. You use Starship in Fish in your terminal. No. I'm using Zesh. The thing you are doing is kind of similar but without a value passing. What do you mean? What value passing? Where? Where am I passing which value? Well, I guess they don't pass the value. So I'm passing the context explicitly here, right? What they have in shift reset, in the delimited continuation, so like reset and shift, right? What they have is that this context is implicit. So you always shift to the closest reset. But I can technically have multiple contexts and I can shift to whatever, like I can have multiple resets and shift to whatever I want. You don't, you only have CC. What do you mean? Hold on. They pass values in and out of call CC. Oh, yeah. True. True. But when I was implementing the effect system, then over here, we are... So for example, right? For example, in order to perform the cancel operation, right? I'm going to perform the... So I need to pass the cancel value into the current continuation, like sometimes, right? Or maybe I don't have this as an example, actually. Or do I? I guess I don't. Yeah. Yeah, I'm not passing value into the thing. You are right. I only have the current continuation. I can make it take some arguments. I have said okay, I have said some doubts. Now my job is here is done. I'm going to dinner. Hold on. Hold on. I think so the thing is. So the thing is. You are right. I think my implementation is incomplete. That's what it means, right? So whenever I am performing the shift operation and awaiting this, right? So this should be replaced with some value, right? So I can have let value be this. So when I'm calling the current continuation, I'm going to call this with some value, and this value is going to be replaced over here, right? So that's the missing part. You are right. It's not going to be replaced. It's going to be like the value of this shift operation, right? Replaced. All right, we're going to replace it, sure. Yeah, I guess none of my examples actually use this, like let value be this, right? But for implementing some of the effects, we actually need it. Okay, fine. Let me see if I can fix the current thing though. Cargo run. Because for some reason we are stalling here and not doing anything right now. Let me actually have dinner, alright. Have dinner. Maybe when you go back I will have the additional argument too. The arguments. So that we can replace something. Right, because the shift right now returns nothing. I want the shift is the operation that should return something basically. But why am I right now? Deeper, deeper, back and deeper. So we went deeper, deeper, back, deeper, right? And then after that, it's the end. So something was wrong here. Kuvi, sorry, I know you are deep in shifting CC pooping, but gotta check you're all alive. Did you mention you are out of job? What's your plan? Did I mention that I'm out of job? No, I did not. Did they like I recently stopped streaming for a little bit because I was doing some work, and now I have done this work so that I can go back to streaming. I don't have I don't have a job where I'm like working every day. I have some things that I can do sometimes, you know? Does that make sense? I'm not employed. I'm self-employed and I'm doing work sometimes so that I can have some money, but part-time job. It's not even part-time job. Part-time job is still like different. It's like it's contract work, contractor work. And perform an action. Okay, so when we what kind of job? Looking for a job that I don't have to work 8 hours a day. I mean, it's not a job. You can do freelancing. That's like kind of similar thing. It's like I'm almost doing freelancing. I'm just working mostly with just one company. It's like when they need me, I work. When I don't need me, I stream. Or are you lying to make us worry less about you? Skim through the limited continuation. I have no idea what it's all about. Yeah, I think the wiki page is very bad. I think the wiki page is very bad. So like, but am I still getting paid? When I don't work? No. I'm only getting paid when I'm doing the work, right? So I just earn money, then I leave off that money, and then I earn more money, then I leave off that money, you know? Like it's kind of same as working every day, but I just don't work every day. So I don't earn money every day. Doesn't mean that I don't have money, right? I'm getting paid when I do work, and I'm not getting paid when I don't do work. It's simple as that. If I wanted to, I could, instead of streaming right now, go and do some work and find some more work to do. But the goal is we finish the link cider and then we get paid $1 million shoulder so that I can never work again, right? Right, Davey? Right? We make our game, make a fortune, and we don't ever work again. All right. Unfortunately, right now I'm a little bit distracted. I mean, it's not like I'm distracted. I'm right now. What I'm doing, it's like it is for Linksider. It is for me making the game. Technically, can I not do this? Yes, but this is also interesting, so it's okay. If this takes too much time, then I just go back and I ignore the problem that like, and I do it some other way. But whatever. That's the real purpose of the entrepreneur. Fuck 9 to 5. Yeah. Yeah. Okay, so I'm doing the shift. I'm not panicking, so like this happens, right? When it's time for break, check this out. It's a cool lesson for complexity and complication, but also a brain teaser of a game. Alright, fine. It's always time for a break. The Tetris effect. Oh shit, what is this font? It's very hard to read. Controls for people with 3 hands? What do you mean? What do you mean controls for people with 3 hands? How many people have you seen that have 3 hands? Huh? The game between new guys? And keyboard illustrations? What? After viewing the Tetris movie, I found myself lying awake through thoughts racing. It's a common occurrence. This time I was fixated on how to create a 3-dimensional version of Tetris. Now, Tetris is notoriously difficult to express in 3 dimensions. In 2 dimensions, the player can clearly see all the pieces. However, extend this into 3 dimensions and the pieces begin to obscure one another. There have been various complicated solutions to what I call the obscuring problem, involving moving cameras or partial transparency, or even arranging the block in a cylinder, but in my opinion, none of them have successfully crackled the complex simplicity of Tetris. There's a big difference between complexity and complication. Complexity is often born of simple beginning. In the case of Tetris, the simple set of tetrominoes, 4 joint blocks in each possible combination, fall into a box to make lines. That what could be more simple? And yet it combines to make a complex puzzle which taps into a deep psychological need to tidy up, to fill gaps, to complete a thought and file it away neatly. This complexity is an emergent property of a simple formula. It is non-zero sum. Tetris movie, gonna watch that. I watched the Tetris movie, it was pretty good. I liked it. The complicated solutions to 3D Tetris added a dimension, but necessitate a load of cumbersome new controls to work around the problem they introduce. The obscuring problem. So lying awake in bed, and I thought it might be possible to eliminate the obscuring problem by using symbolic 3D environment, where objects would reduce in size as they recede in depth, but would not converge on a vanishing point. This way, if you used rings to represent blocks, you could see through the rings in order to other rings in the background, giving you access to all the information in the space. Watch out for the new terminals 2 3 dimensions introduce some curly combinations. New guys. This version of the game is playable on the desktop and is really proof of concept. I am almost finished a mobile version. Sign up to be alerted when it's out. No to terrorist copyright lawyers. I don't intend to develop the game further than this or monetize it. Please don't sue me. Hit return. Okay, I understand. How do I play this game though? How do I rotate? What is the controls? Controls with people with 3 hands. Okay, I actually understand the control. Easy. Okay. How do I make it go down though? X? Oh, X. All right. There you go. How do I make things go left and right? I guess WASD. Okay. Makes sense. Oh, and I can move backwards and forward in the depth. Okay. All right. Makes sense. Makes sense. There you go. All right. Okay. This is still confusing though. I mean, I understand. So like the size of the circle is basically the other dimension. Every size of the circle is one of the 4 like depth pieces. You have 4 4 depths basically. Okay. Nice. Unplayable though. Not really much playable. I mean, it is. It's just too many buttons, you know? It's no more simple rules like in the regular Tetris. It's just actually unnecessary complexity at this point. I think. Okay, so what are we trying to do here right now? I'm trying to understand why my function stops working, right? So we are back to depth 1. We're back to depth 1, and then we never finish for some reason. Seems CC could be useful for cooperative multi-threading in embedded devices with no full-scale threading. Cooperative multi-threading is called async await. You can already do that in Rust using async await. So like, yes, but you can implement async await using that stuff. So it's like it's a building block that can be used to implement a lot of things, including async await for cooperative multitasking and like to do other stuff. You can implement a lot of the features that you have in your regular languages using this thing. Like one of the examples that they have here is they implement the return keyword, right? They implement the return keyword using this thing. So you don't need to have the return as a keyword in your programming language. There's just another example, I guess. Thanks for the raid. Yo. La roba. How was your stream? I'm not really doing much today. 5 hours and 20 minutes? What the fuck? I'm doing literally nothing today. Maybe I should like, I don't know. Maybe I should think about this thing off stream. But still. Let me just try and fix this thing right now. Why is my program never finishes? Continuations. Control, yeah, call prompt. Yes. Abort CC. Call comp. Abort. Yes. Yes. Prompt control. Among the earliest operators for order control, the essential reduction rules are prompt. This is valid. Prompt something control is prompt. There you go. Prompt control. So I think what I'm doing is shift reset. I'm not sure how this is different from prompt control. It's a little different. I still think that it does not explain it very well. Maybe. Whole chapter 10.4 is about continuation in Racket. Yeah. So Racket is like another Lisp language, right? That has all those things. When you search for shift reset, there is also this thing that comes, which is the GUIL. I'm not sure what GUIL is. What is GUIL? GNU Programming and Extension Language. Yes, like another one. So far, all of the examples that I have seen, they are all Lisp languages. Like it is more than dialect of Lisp and descendant of scheme. All right. Okay, I actually have a bug somewhere. Oh, I think I know why. Because I'm literally calling this await, right? So like, hold on. Self-continuation. Yes. And to continue running the executor. Because, yeah, so what I did earlier is like I allowed to call this shift operation multiple times, which means that when I did call the shift operation, I need to replace my current continuation with this new stuff. Shift argument. This is this returns me a future. The continuation, the new one. So we do self continuation. Is this? Is that right? And then eventually we run the future to the completion. Okay, there you go. There you go. Now it all works. I found the bug. Now we run it to the end. Easy. So what is this example? Again, we are entering depth 0. We are going deeper, showing transition. Entering depth 1, showing transition. Entering depth 2. Then we're going back. So exited depth 2, now in depth 1, we're showing the transition of going back. Going deeper, show transitioning to going deeper. Going back, going back. All right. Seems like I have fixed the problem. But as you have said, this is not a good example still, because you have implemented the same output using a different. So like, how do I make it? So like, I think the complex part about this. So I'm trying to write a command line program, right? And the problem is, how do I make two things run at the same time in the command line? How? Right? How? I need some library to do terminal stuff. Rust terminal, like, I don't know, TUIRS, maybe this thing. Concentrated the payback, the biggest benefit of CC, then minimize the setup to showcase the payback. I mean, this is what like I'm trying to. Yeah, the biggest benefit of CC is like specifically this. I think this is exactly what I was doing. I'm trying to minify my example from my real code in my actual game, right? This is the minimized example. It is minimized too much, which like makes at which point it doesn't make sense to use this abstraction anymore, right? Because it is too minimized. So I actually need to make it a little like harder. I guess the biggest problem is that I'm trying to do two things at the same time. And how do I do this in a console application? Is there any alternative to just actually rendering something? Or if I may say that this operation happens like over time, what do I do here? Instead of just doing the printing. What is the payback? To be able to play the transition animation when going deeper and or getting back. Yes. It's all about the transitional effects. That's trivial with sequence of prints. The transition, the animation. Specifically, I want to compose two animations together, right? So my actual game is something that is being rendered. The thing that I was transitioning from is something that is doing the rendering, right? And I want to compose those two things into like an effect, right? So which means that two things need to be happening at the same time for me to compose them. So what is going to be happening at the same time is the continuation of the current function, right? And something else. So I'm composing my current continuation with something else. There's something about the transition being concurrent painlessly, or the trigger, or waiting until end is cumbersome normally without CC. Well, normally I would have to like be very hello girly. How are you? How is readme? Not very good, not very good. We didn't make any progress on the readme. Piccorly. Hello. I'm trying to make progress on the example, right? Before writing a readme, I need to tell people why, right? And in order to show them why, I need an example that is hard to implement without this. So I guess, yeah, so like this example is not very good, this example is not very good. Like, what example is good? I have no idea. I feel like we're close. We just need to. It's a good practice to show. This is the common thing and very cumbersome and verbose than coded normally. Yes. It is like, you know, before in Rust async await existed. You could still do futures. And it was very cumbersome and verbose. So when Rust have implemented the async functions, a lot of code became less cumbersome, right? It's kind of the same, but I'm not doing futures. Too bogged down by thinking small. I don't know. I think I'm thinking big. I'm trying to like implementing effect is thinking big, I think. So far my thoughts were explaining that this is needed because this is so like I want to use this like call CC. This is technically not even a thing. Like were you here when we were looking at Coca programming language, right? So this is like so I can use this to implement the effect system basically. All right. Think big. While we are raising up from the dungeon, we could execute PHP on the side, write an entire Facebook as the tradition animation ends. You're also a real world billionaire. Someone already, someone already linked this earlier today. The PHP Tokyo use async Rust library from PHP. Somebody else already linked it earlier today. Okay, I mean technically, I did make some progress today, right? I didn't do nothing. I actually improved my implementation of the shift reset so that I can use the shift operation more than once. Before, I could only use it once, and now I can use it multiple times, which is good. Nice. Progress has been made. But no progress has been made on me trying to explain this stuff. Maybe I don't even try to explain this. I just use it. You know? I just thought it's a good idea to try and talk about it. I don't know. Yeah, and also like Nerdsel said, this is good thinking. Just use it for myself, right? Like I make my own game engine. I don't need other people to use it, right? I just use it myself. Whatever. I just thought that this is a more generic thing that could be technically interesting to other people. That's the thing, you know? That's why I wanted to do this, because I think this can be interesting to other people, not only to me. This is small enough, this library. This is useful. This is obviously useful because this has been used in other programming languages, right? It exists already. It's not the thing that I have invented. I just have invented, I mean, maybe someone already did it, but I mean, you know, what am I making? I'm trying to, hello there. I'm trying to make an effect system in Rust. Do you know what it is? And I was trying to understand how to explain what it is to other people, because if you don't know what it is, I'm not sure right now how to tell it to you. Like we have tried implementing these examples here, right? But other than showing you the examples, how do I tell you? I have no idea. We normal people, we just need someone to show some light, show the stuff that can be done 10 times easier. I have no idea what an effect system is. All right. Do you know Rust? What do you know? I can try. Okay, since you are new here, maybe I can try talking to you and maybe we can come up with a good explanation of the things. Yes, you somewhat know Rust. like I'm also trying to minimize my surface of like what I'm trying to explain, but not trying to explain the entire effect system, but only explaining one operation, which is the shift reset, right? And by maybe because this is too minimal and too fundamental, it's even harder to explain it because it's just a part of the implementation, kind of. It's easy. What is easy? Rust? Rust is easy, yes. Got frequency. Hello there. Or if it's easy to explain the effects, maybe. But you can try and explain it to us. What happens if I search for effect system and on Wikipedia? In computing, an effect system is a formal system that describes a computational effects on the programs, such as side effects. An effect system can be used to provide a compile time check for the possible effects of your program. The effect system extends the notion of type to have an effect component, which comprises the effect kind and a region. The effect kind describes what is being done, and the region describes with what parameters is being done. Does that make any sense? I mean, it doesn't even make sense to me when I'm trying to read this wiki page. Can you put a timer in what you are waiting so you can sleep a few seconds? Maybe. You know what? Maybe. Maybe we need a timer to make this example slightly better. So you know, like this transition is like happening over time, right? So let's make a not one print, but like couple prints here, right? So like if I do this print like multiple times, I guess it's easier to do like for like, I don't know, let's do 10 times. We do print showing transition and then we do like sleep for a second, right? Something like this. Cargo add Tokyo. I guess we are all going to add Tokyo. Features, runtime, multi-thread. Fine. More dependencies, of course. I mean, for the sake of the example. Tokyo is something that people are like familiar with, I think. So maybe it's going to be okay. So we do Tokyo, task, sleep. And like also this way I'm combining this with already existing async code, right? Tokyo, task, sleep. Tokyo time duration from sex F641. I don't know. Something like this, maybe. Tokyo task. Wait, where is the sleep in Tokyo? Is it not in task? Sleep? Or did I not? Oh, feature time. Okay. We need to add a new feature. Cargo. Cargo add features time. Okay. Cannot find function sleep. Why can you not find function sleep? What do you mean? Cargo check. Tokyo time sleep. Okay, it's not in task. I think last time I tried using it was in task for some reason. Oh, maybe it was in task in like in async std. That was weird. Okay, so there you go. Cargo run. There is no reactor running. of course, because we want to do async function main now and do Tokyo main, right? And this is not the one. Hold on. This is another example. I think we can comment this out. This is the one, Tokyo main, async function main. So we don't need to block on. Okay, there you go. Everything is async now. Main function is not allowed to be async. Huh? Cargo check. Could not find main in Tokyo. I need some other feature. Tokyo. Why is this feature not enabled by default? Let's just do the false features, right? Cargo toml. Tokyo features. Let's just do full here, I guess. Okay, now we don't see anything on the screen. Org. So if I fix that, it would be nice. So block on is no longer needed. Oh, hold on. Reset. I need to await. That's why we don't see anything on the screen, because we need await. There you go. Now it should be good. Okay, there you go. So this is working, but when we're showing the transition, we don't see the transition being shown multiple times, right? So it's so yeah. The reason is because whatever is happening inside the game itself is happening too fast, right? We want it to be happening over time if we want it to be like that, right? Let's do what's going to happen if I do I think in order for this to work with actually work with Tokyo, I need to do some more changes. But I need the game to be running over time, I guess, which will mean that my actual thing over here, actions next. So I think after we got the action, I need to sleep here too. Tokyo time, sleep. For 1 second. Sure. Is it going to work? It is. There you go. So now when I'm showing the transition, I'm showing the transition in like two places, right? So why is that? That is because the previous transition is still being shown, basically. That is why. Right? It actually works. Okay. I guess what I mean is that I can make my implementation more efficient. Because I'm just pulling the futures, ignoring the wakers and shit. Let's do over here. So we're going to pause by 0.1. So there you go. So this is me showing the transitions. Does this make sense? This doesn't make like a lot of sense right now. I think when showing the transition, I want to show a specific thing here. So what if when I'm showing the transition, I'm showing like what this transition actually means? The transition is going to also say like description, I guess. Current transition. Does that make sense? May at least currently borrowed value depth. Yes. Move. So there you go. We were showing the transition of us entering depth 1. Then we were showing the transition of entering depth 2. So over here we're exiting immediately though. Are we continuing yet? Yes. I'm trying to extend this this example so it's like more interesting. Can you come up with a good example, Nerdsoul? You know what it is, right? We are continuing. I have added Tokyo dependency so we can have something like happening over time here. Do you want me to think? Okay, maybe not. Maybe not. Did you finish your own like ECS stuff? Seems like you have been studying that for a long time. When are you going to finish your ECS? Oh, you're waiting for the response. All right. Well, if you're doing nothing, then of course, why don't you think on my thing then? You want to have effects, right? If you help me, we're going to have it sooner. Just apply Davy's example, pooping and peeing. You want a new language? But what if we can actually have it in Rust? New language is something that is requiring a lot of work, right? So, if we can use something that is existing. You don't think you want effects in Rust? What do you mean? But you still want the features of Rust, right? I mean, a lot of things are going to be deleted, like, for example, async. I mean, that's not going to be Rust anymore at this point, right? I mean, they are current. You don't want all Rust features? What Rust feature do you not want? I think I don't want. I mean, no. I think I want all the Rust features. I just want some additional, yeah. What is there wrong about? You really just want ADT, linear affine types, and trace subclass, I think. So what do you not want? You still want to have async sometimes, right? So, but this is just going to be a library feature, whatever. It still is going to be there. You still want to have. You're saying trace. Like, you have also like existential types is another thing that they are thinking about, right? And stuff. Whatever. Charades. Linear affine types and trace type classes. It is still kind of going to be Rust though, no? Anyway, whatever. How can you go to the matching bracket, by the way, in this editor? Go to matching bracket. MM. Press M. If I my M is match. So we can surround, we can go to matching bracket, we can surround. What if I don't select anything? Surround, add this. Hold on. M. Oh, select around object. Select around with a parenthesis. Okay. There you go. Oh, actually that is nice. So we can actually select surrounding like expression or word. Hold on. M-A-W. Why is this, by the way? This looks wrong. Match around word. Why does this select everything to the beginning of the line too? If I want to select this word from inside, M-A-W, M-I, select inside object. Oh, around object and inside object are different things. Inside word. So select inside word and then replace it with something else. In Vim, I would just do I would just do CIW to change inside word, right? CAW. Okay, I had to bet Goofy. Good luck with your system. Thank you, Rinks. Rinks probably knows all about Rust at this point by watching my streams so much, right? But you go in to do programming yourself now, Rinks. C. Hold on. What did you say? CAW? CAW? No, hold on. C already turns me into insert mode. Or are you saying what I would do in Vim? CAW in Vim? I usually end up doing BEC. Yeah, BEC. So like go to the beginning of the word, go to the end of the word, and then change, right? That seems like, I don't know. This specific thing seems like it's better in Vim. But you can also try Alt-O-I. Oh shit, what is this? Alt-O-I? What? So, hold on. Alt-O. How do I search for it? Alt A-O. How do I search what this command does? Like Alt-O. Where is it? I don't see it. It's the top one? No, the top one is Alt-O and then Alt-Up. Right? I just pressed Alt-O. No? Oh, it's two commands that are the same thing. Oh, okay. So like, you have multiple. So like, if I do Alt up, it's going to be the same thing, right? Yeah, okay. It's just my multiple key binds to the same command. All right. Fine. I thought that you like had to press them in order. Okay, so this is like the tree sitter expanding selection, right? So that I I go to the like containing thing, word, and then the entire item, and then the entire argument, and then the entire function arguments, and then the entire function signature in the entire function. All right. Okay, makes sense. CAW can be mnemonic. Change a word. All right. Let's do this. No, let's not do this. Let's sleep over here too, I think. And then we're going to see more. We're going entering 1, entering 2, back to 1, entering 2, back to 1, back to 0. So this kind of resembles a little bit what I'm going to have in the actual game, right? So instead of just printing, this is me rendering to the screen the transition, right? Underscore stream selection. It doesn't do anything. Oh, you mean trim selection? Wait, hold on. What does it mean, trim selection? If I select this and then I do underscore. Oh, you trim it. Okay, I understand. Not really useful, but helpful. What do you think trim is? I don't know. I for some reason I thought that like it went the other direction. So like if I expand my selection, then I can go back. Like how do I go back into my duration now when I have selected this? AI. Nice. So like out and then out inside. Yeah, I remember. I remember that the tree sitter plugin in NeoVim did like kind of similar thing. I think I had different keybinds. I never had a chance to use it too much, but I thought this was a good idea to have to like select things. So like this is how I select the entire match, right? Can I select the entire match even faster? Because like tree sitter knows about these things, right? It's like this to select next to something. This. Go to next diagnostic, go to next type definition or previous type definition. So yeah, this is the only type that I have. Next function, next function, next function. Okay, nice, nice. Nice. Next parameter. And parameter including the parameters that I use to call the functions. The macro parameters are not these things, I guess. They're, okay, makes sense, makes sense. Next test. I don't have any tests. Who needs tests anyway? What about paragraphs? Add new line below, add new line above. Nice. Okay. How to add line? You use the right bracket. There's a menu over here that. Hold on. Let me move a little bit. Let me move a little. Do you see it now? Hold on. Where do I move? Over there. You do space and then it inserts a new line. Okay. The real question is, how do you press both? What do you mean? Okay, let me try to do one last thing. If I'm not going to do any progress on the README, at least can make progress on the implementation, right? So just like Nerdsel said, our shift operation right now, our shift operation cannot have the value, right? And I want to expand this to be able to for this to return a value, right? So this is going to return some value. How do you press this? Do you use your hand and press with ring finger? Hold on. Actually, I don't use the ring finger. Hold on. So your question is, how do I write the brackets? I press the left bracket using my pointer finger. I press the right bracket using my middle finger. Am I doing it wrong? Oh no. What is wrong with you? What do you mean? What? So okay, what are you going to? What fingers are you going to use if you want to do a curly bracket, right? Like this thing. Are you pressing shift with your left hand, or do you press both buttons, the shift and the bracket, with your right hand? I think I do both. Sometimes I do this, sometimes I do that. Right hand shift pinky. Yeah, that's what I do. But sometimes I actually use two hands. I think most of the time I'm not though. I think most of the time I'm using one hand with pinky for shift and the pointer and middle for the brackets. And same for like the round brackets. You never use the right shift? Oh no. Okay, so what is the value here that I'm going to return? This must be a generic thing. So this function I don't know what to call this generic argument. It lets me call this value, I guess. This is going to be another generic argument. And so the shift operation is going to take in the closure, right? So we're going to do fn once. Hold on. Is what I want here an fn once, and inside here is going to be fn once, taking the value and returning the continuation. Is this the thing? I also like ampersand to align text. Ampersand cannot work with multi-line selection. Align cannot work with multi-line selections. Huh? Oh, where do I use it? Align cannot work with multi-line selections. Do I select a word and then I do align? What do I need to select? Multiple words? I never like get the chance to try out the multi-cursor yet in Helix 2. You need multi-cursor and then you align the cursors. Oh, okay. So I'm going to have a box in Fn once. Is that right? We have another lifetime here. Is that right? Over here we do boxed in Fn once. We have Fn once with Fn once. Ah, inside. That returns the continuation. Value. Value. Is this the correct signature of what I'm trying to do here? Let me comment the effects. But the shift has an incompatible trait. Expected this, found that. AS. Control S or Alt S splits the Control S. No, Control S saves the file for me now. I used your keybinds, Nertzel, by the way. I saw you use Control S to save files. You are using your Helix just like VS Code. Control S doesn't do anything, I think. You mean by default? No, by default it inserts the jump bookmark or whatever it's called, you know, so that you can go back to the current position, I think. Can I search for Control S? Is it going to tell me the default one? The only reason for that is you mistype :W too often. Yeah. I think Control S is easier. I had saving the file bound to Control S in my Vim too. Okay, hold on. What is wrong? This looks exactly the same, no? Cargo check. Current selection to the jump list. Yeah, exactly. Do you use the jump list? I don't think I'm using the jump list at all. But it is useful, I think. I'm just not used to using the jump list. Okay, let me try. So this function is going to be called not by just the continuation, but it's going to be called with a function that takes in the value, right? That we can replace. our shift operation with. Okay. So move. See. Okay. So over here we have the value. And I guess this one needs to be boxed. Okay, so the value here, we just ignore it for now. So yeah, whenever, okay, so this value is going to be called from inside the shift hand, the closure that I passed to shift. All right, and I need, so yeah, this is going to return the value, obviously, which means that this needs to be returned. So we expected value and found unit type. So we are going to return pending ready. Oh, so this is going to be another implementation then. So the future is going to be continued when we call this, right? So I think I'm going to create the one-shot channel here. Actually, I think one-shot channel, right? Sender, receiver. And over here, I'm going to do sender, send, value, expect, WTF. All right. Another one. And over here, it's going to be not poll FN anymore then. It's actually going to be the receiver that I'm going to await here. Receiver. Mismatch types found enum result. Expect. Huh? There you go. What is this? Shift has incompatible. What do you mean incompatible? Can you see any difference between this and that? Is my Rust analyzer being stupid again? Okay, whatever. Let me try cargo checking. Oh, expected. Oh, yeah. Okay, I actually see the difference. This should return value. There you go. Okay, and now main. Okay, so now this is not just the current continuation. I'm going to continue the current continuation with a value, right? So this, when I'm awaiting this, I'm basically giving a value to this thing, right? Nerdzel. Right. So I'm providing a value over here when I'm going to call this function. The value that I'm continuing the current function with. So I'm providing a value to this await. You like that? Hold on. What is wrong with my brackets right now? I can try implementing an effect just to like as a proof of concept. What is the effect that we can do? I guess I can implement a linear effect, but right now instead of doing the linear effects using actual handlers, the generators. Hold on. Shift reset. Hold on. No, it doesn't work yet. It doesn't work yet. Shift reset. Shift I while is even more insane. Shift in while is even more insane. So it would stack multiple continuations. What do you mean stack multiple continuations? We have shift in while right now, right? In this example specifically, right? We have shift inside while. This is what is happening. We're doing the shift operation inside a while loop. So it doesn't stack multiple continuations because like in Rust, I cannot like clone my future, right? So when the function has been executed only partially, I need to, so like before continuing the, so basically before creating a new continuation, I need to use up the previous continuation. Does that make sense? Maybe. Value might not live long enough. Yes, so I want the value to also live for the same lifetime here, right? And then we go to the definition of the trait, and we require that the value also lives for this lifetime. Okay, and then we have the sender. Cannot borrow sender as mutable, so like the sender must be mutable. Okay, first, this is something that I don't need. Okay, I don't have any more warnings. So when you use one in shift, continuation will continue and call another shift. Yeah, exactly. So like when you call the continuation, you continue executing your function. So you're continuing your loop and you're creating a new continuation. I mean, you don't create a new continuation. Continuation is basically the object of the future that is currently being executed. So like the current function. So in that sense, it's like simple, I think. Did it make sense? I was questioning what I'm saying. No, it did not make any sense? Alright. Well, I think I'm going to give up on trying to explain what I'm doing because it is too hard to explain. I don't know. I need to like something needs to happen that I like suddenly understand how to explain it. I don't know. Anyway. So yeah, I can continue the current continuation with a value. So let me make you like just an example, right? So like value is this, right? So this value, the value when I'm awaiting is going to be provided over here. So if I'm calling this with a value of 10, then we can assert that this value is 10, right? So there you go. There you go. You start by understanding how people communicate. Yeah, communicating is not my thing, I guess, right? I mean, I can just link you to the Wikipedia page, right? But I mean, if Wikipedia does this bad job at explaining this, it means that like how like because this is too nerdy, right? What will happen if you add stuff after continuation in shift? It will execute it multiple times. What happen if you add stuff after continuation in shift? It will execute multiple times. No. I cannot execute multiple times. I'm not even using any unsafe right now to implement this, right? I cannot like break Rust rules. I cannot continue executing multiple times. This is one of the things that like scheme programming language allows you to do, to call your continuation multiple times. I do not, because like we're building this in Rust. Rust does not allow you to clone the async functions when they are being turned into futures. Those futures don't implement the clone trait. We have basically a linear, yeah, our continuations are linear. That's true. That's right. There you go. Nerds will understand something. Okay. So because of that, we don't like leak, like duplicate resources, right? I understand. Boom. Ah, good job. Good job. Okay. So there you go. This assertion actually holds. So basically, you are giving over here, it's not the continuation, it's a lambda, right? That's what you are talking about, Nerdsel, right? So this is C. This is, for me before, it was just a continuation, but now it's a lambda that takes as an argument the value that we want to continue the continuation with, right? A lambda, yeah, a closure, a function, whatever. So defer will only work once. Yes. Hmm. There you go. It actually is a lambda. There you go, Nerdsel. Thank you for making me realize that there was a missing piece in my implementation. Now nothing is missing. Unfortunately, it's a little like weird that I need to call CC. I need to call this with an argument which is nothing, which is a unit. Kuviman is Nick Burns, your company computer guy. What does that mean? That's a reference to something that I'm not familiar with, I'm afraid. Okay. Saturday Night Live. Okay. Yeah, I'm sorry, I'm not watching American TV, I guess. I know what Saturday Night is, right? It's like the show where they talk. I think I saw it once. He would explain himself, he would just tell the users to move. Oh, okay. Deeper, deeper. Back and then deeper. This suddenly looks a little wrong to me, but alright. We are going deeper, deeper, and then back and then deeper into the dungeon, which is a simplified version of our game here. Okay, what about this one? This is the old example. Sync function example. You know what? Let's yeah, so we are calling the current continuation with a value. There you go. And then we await it. So this was needed to be changed. Let's make it actually a crate. I feel like I have created something useful. I can make it actually as a standalone crate. This shift reset. Let's call this, you know what? Let's call this just shift reset. We don't have effects yet. Or whatever. So this is a separate crate that is called a shift reset. Right? So that you can play around with it. If you want. Let's move example to examples folder. Yeah, exactly. And we have 2 examples here. We have 2 examples already. Maybe we can come up with more examples later. So this example is very short. I'm not sure how useful this example is. That example is bigger. We also need another example where we're continuing the continuation not with just nothing, but with a proper value. Okay, I'm gonna go make my game better. Using the continuations now, right? Am I right? Are you using the new async stuff that I implemented in Gang, or are you still working with the old school like state management? Okay, so I'm going to move source shift reset into source. No. Hold on. How am I actually going to do this? Because I want to implement the effects on top of that, but I want the shift reset to be a separate crate because it's useful on its own, I think. Do I have two crates in one repository, or do I open a new repository? What do you think is better? I guess just one repository is simpler. Okay, the effects is going to be the one of the examples for now. They're going to live in the examples, maybe. So I'm going to move the shift reset into source librs, right? And then I'm going to make directory examples. I'm going to move source main into examples. How do I name my examples? Let's make them simple. No, let's make it deeper. Right? So this is our deep example. And then we're going to also take a part of this, which is the simple example. This one. This one is a simple example, right? So this is not a mod shift reset anymore. This is me use shift reset star, right? Okay, then let's open examples simple rs. So this is another example, which is much simpler. Use shift reset star. Shift reset is the crate, is the name of the crate. What it's going to be. This is going to be main Tokyo main. I'm going to use Tokyo. That's something that people are used to, right? Okay, the name of the package is going to be not Rust effect, it's going to be shift reset. The dependencies. Tokyo is going to be the dependency for example, so like dev dependencies is going to be like the crate itself is not going to depend on Tokyo. Not sure about the other things. I can like trim the dependencies later if I want to. Cargo check all. Examples. There you go. Cargo run example simple. So this is the simple example, and this is the deeper example. Right? So we have both. Nice. Alright. Clippy. Yes. I have changed my Helix to work with Clippy instead of just check. So we are seeing the things. Okay, and then this is source effects, right? This is the effect system. And the effect system is going to live in one of the examples, I think, for now. So I'm going to move source effects into examples effects rs. Hold on. I think this example is going to consist of multiple. So that's how I do it for now. Make dir examples effects. And we're going to move source effects into examples effects effects. because this is going to be like a library of effects that I'm going to migrate into It's So Great later, but not right now. Helix, examples, effects, main RS, module effects. No definition found. Hello? First time, but saw this and thought it looked very interesting. Scala's ZIO brought the concept of an effect system to your attention. I know that Scala is the language that has the things, but I never used Scala myself. The language that made me interested in all of that is the Coca programming language. This one is a research one. I think this is the programming language that implements effects very easily. Right now, we have something made in Rust, but I'm not sure how long have you been here. We have something working. Mostly, I have just implemented the delimited continuations, and the effect system itself is implemented on top of that. The hard part about it that I was thinking I am going to like figure out today, but I didn't, is trying to explain it to other people. So like, you are familiar with the concept of the effect system from Scala, but if you was not, I am not sure if I could explain it to you very well. That is hard. Why can I not go to this inner module? Why can I not? Okay, fine, open. Oh wait, now I can. Okay, yeah, see, like Rust Analyzer is stupid. Sometimes it does not, like I need to restart it sometimes, which is like annoying. Annoying. Okay, over here we have the effect system. This is our example that we have, right? Actually, this is so short that I think I can just move everything into one file. Hold on. Remove examples, effects, main. Just move examples, effects into examples. Remove directory, example effects. There you go. Open examples, effects. Okay, there you go. It's just like one small file. So here we go. We have three effects defined here in this. The logging effect, where we can log. The cancel effect, which is similar to a return operation when we return from a function. The file system, where we can read files. We don't have the an example of an effect that is like async, you know, where we continue the continuation later. The logging is where we continue it immediately. And so these are linear effects, and this is unwinding effect, right? So just like I started this in my README, I think I can categorize the effects into these things, which is tag effects, which is like just a tag on a function. Unwind effect, when you unwind and then like just go up the stack basically. The linear effect, which is just a function call, and the delayed execution, which is like async await. Yeah, so we don't have an example of this. But the example of this is literally already async await. So I like the way I have this implemented, I think, is it already works in combination with async await. So because I have implemented my effect system on top of async await, you just use async await that is already there in the language, right? But is there another example? Is there another example? I don't know. And also, instead of my effects being like actually effects, the way I do this is I am passing them as an explicit arguments. I think there is also an advantage to this being explicit. So this basically is passing the handler of the effect into a function, which is kind of similar to specifying that this function has the log effect and the cancel effect, right? I'm naming my handlers and so that I can access them. Might be a good thing. All right, so over here we have the shift operation. Type inside async block must be. Oh, okay, yeah. So when I'm shifting here, I need to shift with value of nothing. Right? Can I do as this? Or does that not work? What if I do let underscore nothing be this? Okay. Then Rust and is okay. Alright. This is nice. Does this work? Cargo run. Example facts. Yes, so this works. This works. The hardest part, I mean, not the hardest, but implementing the handler is a little too verbose right now, right? Other than that, I think I like how it looks. There is no magic in this code. There's no macros except for this async trait, but that's all right. And I think this is what I like about my implementation compared to something like the effing mad, right? Or the other one. So they are using nightly features of Rust to implement the effect. And they are also using macros a lot. I don't like that. Okay. But I think we can still use macros to like make this one shorter, right? So we are creating the cancel handler here. Creating the cancel handler. And so when we call like the cancel operation with a value, we are using our like shift reset stuff to implement this. Right? So all of that, technically, how would it be written if it was not this verbose? I would say x is handle. I mean, I don't know, handle cancel, I guess. Cancel is kind of like the unwinding effect. Maybe I should show you how to do the throwing of exceptions instead. Cancel is like weird because it's not very familiar concept usually. Okay. Handle cancel. Handle cancel. So we're going to have the cancel handler inside here and return the async stuff where we do simple log cancel wait, right? So yeah, this is what it would look like, I think. So let me create. Let me make it work. Actually, so I'm going to create a function that is called handle cancel, right? Async function handle cancel. Over here inside, I'm going to receive a closure, impl fn once, which takes in a something that implements cancel. Impl fn once, which takes the reference to the canceller and returns a future. So basically it takes an async function as an argument. Future is a future that returns key. I make it a generic one, right? So I think this only needs to happen once when I'm defining my effect. I'm defining my like syntax for writing sugar. So like this is still a library function. So if this is verbose, it's all right. I think I can do this without macros still. Сначала делаю сборщик мусор для Раста, а потом отлов ошибок для Раста. Что дальше? Did you use Google Translate? Again? I think you were the person who used Google Translate to pretend that. Yep? Okay. Maybe I confused it with another one. Alright. Okay, nice. It is still is better, like, because I'm talking English and there are people here who don't understand Russian. That if, like, I mean, I know that you can speak English in chat, so I would appreciate if you do that. Right? Consider choosing a more descriptive name. Just underscores and digits. More descriptive name for what? Hold on. Okay, there are some syntax errors for now. Where is the syntax error? Over here, of course. Oh, wait. There you go. Type is an async fn body must be known. Simple. Well, simple is specifically about cancel I32. I guess we don't know that here. So if I say that this is I32, maybe not. Maybe I need to fix this one first. Yeah, so over here we don't do simple. We do f. This is the function that passes an argument. Then I'm going to call this function with the reference to cancel. F cancel dot await. Call expression requires function. What do you mean? F is a function, right? F is a function. Oh, I cannot have. Okay, yeah, I definitely cannot do that. I cannot have impl fn once where inside I have impl cancel. That is true. Okay, but I guess I can do dynamic dispatch here. Dynamic dispatch is all right with me. Okay, I'm using boxing and dynamic dispatch in some places, but not in all. I think that's okay. Trade bound didn't cancel. Wait, what is the error message? Trade bound didn't cancel. Cancel is not satisfied. Yeah, that's true, because I don't need any more to have the reference here. The size of our values, didn't cancel cannot be known. Size is not implemented for didn't cancel. True. Why? Because over here. Okay. So like if you have a function that takes as an argument a reference to something that implements this, right? By default, Because this is basically a syntactic sugar for a generic argument. By default, all your generic arguments have the sized trait. So I need to do this, question mark size, so that I can pass in the dynamic trait objects. This is a little bit annoying, like, actually. I think this could be the default. When you are having a reference. So I need to do this all everywhere. Question mark sized. Yeah, this is a little bit annoying. This is not the first time I'm annoyed by that. And then we have lifetime might not live long enough. We need to do async move. We need to do move. No? Cargo check. Hold on. A lifetime may not live long enough. Returning this value, so returning the async block from the closure requires that one must outlive 2. The return type of a closure contains lifetime 2, and this thing... Oh, the cancel. Cancel has a lifetime. Cancel has a lifetime of 1. Yeah, so because I have a dynamic trait here, where do I have it? Dynamic. So this thing, we are going to do impl for a fn once. So this is a lifetime here. A, cancel, a, and future. No, cancel, dynamic cancel plus a, right? That's right. Biggest plus. Is this what I want? Can lifetime just be just a number? Yeah, lifetime. I mean, actually, no. Actually, lifetime cannot be a number. But when Rust reports error messages, it shows lifetime as a number. It's weird, right? Lifetime can be like any identifier. So like you can do whatever you want. Or it can be an underscore. But it cannot be a number. But when Rust is reporting errors, it uses numbers for unnamed lifetimes. Okay, I see what the problem is. So once again, the problem... The problem is that this lifetime is not bound. So like when you create a function that needs to return a future, this future needs to have a lifetime, right? This future needs to have a lifetime, but there is no way for me to name this lifetime because this lifetime is only technically being introduced in this over here. And if I make it here, is it going to work? Yeah, so like this function itself should live for this lifetime too. Argument requires that cancel is borrowed for a. That is right. Okay, fine. I think, you know what? I think, hold on. Like technically I'm constructing the cancel handler here, right? I can pass it by ownership. Handle cancel. So this is going to be an fn once, which takes as a reference the cancel handler. The cancel handler is basically a boxed dynamic cancel t object, Like that. Yeah. I mean, I still have the lifetime for this trait object, so this is not going to work, I think. I think this is not going to work. The type parameter t might not live long enough. Yes, because when you construct a boxed thing, a boxed dynamic trait object, by default, it assumes that this lifetime is static here, but I don't want this lifetime to be static, right? Okay, fine. Fine. Let's try. Let me try once again. If I make it not a reference, but a boxed. Everything should live for this lifetime, basically. Right? Is this going to work? So instead of... Yeah, I will have to pass a reference here. Trait bound box cancel does not implement the cancel. Yeah. So this is also annoying because this is a box, I guess, in order... So like, one of the things that you can do usually, enough effect for me, I go by. Alright, bye-bye. One of the things that Rust has, like... So I have a boxed dynamic trait, right? So this thing over here implements this trait, but the boxed dynamic trait does not implement this trait. Right? So when I'm over here taking a reference to the boxed-in trait, it does not implement the trait. So I need to take a reference to the what the box like dereferences to. So like add star, and that is going to work. There you go. There you go. Cargo check. Okay, it actually compiles, which means probably that it works. Unused variable x. What do you mean unused variable x? I'm in. Hold on. So when you use a debug macro, it still is counted as unused. Is that true? Because I'm printing it out. Okay, let's do print. X is X. This does not implement. Handle cancel. Handle cancel should be a function that actually returns this value, this t. So when we're doing reset, we are using... So we're over here using the shift reset in order to implement this effect, basically. There you go. So this is a generic way of introducing a cancel handler. Go to references here. Nice. Okay. So there you go. X equals 4. Isn't that nice? So here we go. The thing that we have here. We just do handle cancel. Do I need this move operations? I think I don't actually need those. Can I do this? This borrows cancel? Yes, true. So like over here I need to do async move. A little bit nicer. Also, like specifically here, I can just handle the cancel using this, right? So I don't even need to create. Cannot return values turning. Oh well. Yes, I cannot do that. Yeah. That's why I actually need the async move block. Otherwise, it's not being moved. Alright. Fine. Why is this thing formatted as one line instead of this? This is what I want it to look like, right? I'm handling the cancel effect, and from inside over here, I can use the cancel effect. basically. And it is also pretty explicit because I'm passing it as a value here. Okay, fine. Let me do this. Cancel is this. Because then I can just do that, right? I'm passing the log and cancel effect in, and also I have the proper formatting. Okay. Is Nurtle still here? Nurtle, do you like this? This looks pretty cool, I think. If you know what it is. If you don't know what it is, it looks like, what the fuck? Allow that code? Let's not allow that code. Why do I allow? So what is the key for doing fuzzy search? For doing searching inside my workspace. Workspace symbol picker. No, not this. File picker. Like what is the command to like search in files? Global search in workspace folder slash. Global search. This is not interactive though. Which is weird. I have a file picker. And I say function main. I don't see it, right? There is such a thing. File picker in current working directory. Function main. No, it doesn't work. Open last picker. Oh, okay. Nice thing. Global search in workspace folder. Oh, function main. Oh, it actually does work. It is not very like function main. Yeah, it is not very interactive. So I passed what I'm searching for, and then I can see all the search results here, which is okay, but okay. So I wanted to search for allow, because I'm allowing that code and things like that, right? I think I can delete this now. Allow. So yeah, this we over here we allow clippy let underscore future for a reason, because we don't show the rest of the transition specifically. Yeah. Yeah. Actually, is it better to me to drop it explicitly? Drop with a value that does not implement drop. That is not true. It's a future. What I'm so this is a future. Oh wait, it's a pinned mutable reference to a future. So it's actually not. Yeah, yeah, that's okay. That's right. So it's actually only going to be dropped when I'm exiting this function. Okay. If I want to own it, I would have to box it because the select requires that I pin it, I think. If I don't pin it, it's not going to work. I think. Okay, then we just do this like we did before. Where else am I allowing? Nowhere else. This is the only thing. Okay. All right. You know what? I think it's enough for me for today. I did do some progress. I did do some progress. Or do I... Hold on. Effects. Like one of the things is that my log effect is literally implemented just like just as a function over here, the handler, right? So I'm not implementing the log handler using shift reset, but like just as a an exercise. We could implement linear effects using like the generic effect like stuff. So this is literally an optimization that they talk about in the Coca programming language. When your effect is linear, you don't need to capture the continuation. You can just implement it as a regular function call. And we already see it here. Nice. Nice. So like the linear effect is where you call your continuation immediately in the end over here. So like continuation, you just call it. Right? You just continue executing the function as you were. And because you just continue executing the function in the end, it can be compiled as a regular function call. Okay, let me try doing this. Not handle cancel, but handle log, right? Just as an exercise, because this is a linear effect. And I want to try handle log. So handle log is something that requires the function that is going to be handled, and also the logging itself, like something that implements the log functionality. This is like unnecessary, but like the logger itself, right? A reference to impl log. Is that right? So yeah, I'm just going to implement this using reset. Shift reset. Future output is Steam. Yeah, so this takes dynamic log as an argument is the difference. So instead of having the cancel handler, I'm going to call this the log handler, right? And we are going to implement log. I'm going to implement log for this. Log self message string. This is not infallible. This just does not return anything, right? So yeah, when we call the log operation, what we're doing is we are yeah, so we are the reset handler. Reset handler. Why is it ref cell option? I think this is also can be simplified by doing this. I don't need to take an unwrap. I just need to call the shift operation on it. And so yeah, so this is actually the handler for canceling an operation. It's just returning the value forward. But so yeah, I'm actually ignoring the continuation in when I'm doing the cancel effect. But over here, what is going to happen is we're going to call the log implementer, right? Let me actually do, you know what? Hold on, something that implements fan mute with string. So like I just pass a closure to it, the logging closure, right? So over here I do log which is going to be boxed dynamic fn mute string a. There you go. So over here, log handler, I'm passing the log here. Init because I can. Ref selling is not needed. I guess ref selling is not needed in the other one. Shorthead redundant initially. Oh wait, hold on. Why is formatter does not get rid of this? In my VS Code, if it saw this code, it would be simplified automatically like that. Okay, so over here, what I'm doing. Let log is mute self log. And over here, so when we're actually handling the operation, we're calling this with the message. And then after that, I'm running the remaining continuation. And this is a function that takes nothing as a result. Right? Log, this is not a fusion. Oh yeah, okay. This is not even asynchronous. Fine. Now we just have a little bit of lifetime issues again. That's okay. I guess is this because of these lifetimes? Because this is async function. Let me try to simplify this one too while I'm at it. Just not take unwrap, just do this, right? This is so much simpler now, actually. Yeah, this is simpler. Just need to fix these lifetimes. Okay, let me see. So I'm moving this log over here. Is that the only error message? Maybe there's something else? Cannot borrow self-log as mutable as it's behind a shared reference. Oh, that's actually true. Hold on. That is actually true. If this is an fn mute, maybe I can just do a regular fn, then it's going to work. Not really. Cannot borrow self-log as mutable. Yeah, so just a regular reference. Closure may outlive the current function, but it borrows log. Oh, so this closure should not outlive. I think I think I see it. I think I see it. This closure should move this into, right? No? Is that not it? Let's see. Lifetime it live long enough. So this is the lifetime of self. The lifetime of self must outlive A. Why is that? So why is that necessary? I don't think that is necessary, is it? I guess, I mean, technically, because I'm shifting the I'm passing the execution to the reset handler, right? So one of the things that I can do here is I can, I don't know, for example, I can change this from being box to being reference counted stuff, and I can clone the message too. So like, that way I can at least make it work. But that's a pretty big problem. I mean, reference counting the function itself is not a problem. The problem is that I have over, so like over here, I'm passing a reference to string, right? I think this means that my shift operation has wrong lifetimes on it, is what it means. Because this should be allowed, what I'm trying to do here. Because yes, I am moving stuff into over here, right? But because I'm awaiting the shift operation, it means that my continuation is not actually going to escape the current function. This should compile. I think the problem is that I did something wrong with lifetimes here. Oh, over here we have a reference to self. Is this it? I don't have a reference here. The lifetime was not specified. Is this a problem? This might be a problem. I didn't have the lifetime specified. Some other shit doesn't compile now. Explicit lifetime required for the type of CTX. What do you mean? I would check. Example, simple. CTX does not live long enough. Borrowed value does not live long enough. Okay, actually, maybe not. Undo, undo. Okay, I need to figure out the actual, like, the proper way to annotate my lifetimes here. foreground. Okay, you know what? Let's just comment this out and say to do. There's some lifetime issues here. Other than that, still made a bunch of progress today, so it's alright. It's alright. Did do something. Not the thing that I wanted to do, but something. Okay. Some progress. Fog. Okay. Okay, I'm done. I'm done doing nothing. With this. This guy probably knows how to do a Rust properly without doing nonsense like trying to come up with an effect system. Bye, Davey, bye. I kind of want to like continue this, but at the same time, I don't want to spend too much time on it, so that like because we need to do progress on the game. Did you make any progress, Davey, on the link cider yet, or no? So yeah, I kind of want to continue this, but I want to continue the game. So I don't know. We'll see. If Davey says Kappa, maybe I can spend a little more time on this, right? When Davey is going to make progress, then I will make more progress. Maybe that is how it should work, you know? Alright. See you tomorrow. Bye.